There. How's that?
Better.
That's good, Blue.
Now the outside world will be able to hear you.
No. Now the outside world will be able to hear him and know that it is Blue speaking, and not have to guess because they just see Terry lighting up.
Better.
That's good, Blue.
Bit of an echo.
Yeah, I'm muted.
Yeah, I'm muted and deafened.
There's a thingy.
Might be Terry.
There's a thingy of the actual live stream coming back through.
Yeah. My stream wasn't muted, but so maybe that's what it was. We're still on the Go page, so I didn't think sound was just coming through that.
Ex-Penguin, can you hear the rest of us? Or just Blue?
Yeah, I gotta get this lined up better.
Well, now they should hear everybody because you've gone live.
Yeah.
We have confirmation from the Elmings. They hear all of us. Wonderful.
Yeah, well, now Terry's put us out live. I'm hoping they can hear us all.
They won't be able to hear me if I'm muted.
I was going to say, mate. Where's Terry?
You just missed my most intellectual statement ever.
Yeah.
I'm not going to repeat it. I'm not going to repeat it now. Sorry.
Of course not.
No. Okay, what was I saying? Now, see, I've forgotten what I was saying now. Okay, I was looking at a Lindsay for the last Lindsay we're up to. And it...
Oh, God. If you're finding Lindsay, I'm finding Scotch.
Yeah. Think what it's like for us that it's 08:39 in the morning. It's a bit early for Scotch or any other libation, really.
Well, actually, this one, it looks like he maxes out his memory card because it goes for 23 minutes and 48 seconds.
It's usually 27 minutes and 48 seconds, isn't it?
Well, 27. I've got a 27 and 13 seconds. A 25 and 45. 27, 13. 27, 13. Yeah, this one is a little bit short.
We did find one where he actually stopped and actually sort of said he was stopping, didn't he?
He said a couple of them. Yeah.
Rather than it just cut out, and he can't be bothered to fix it, so just puts it up.
Yeah.
But keep in mind that it is Lindsay, and there is no known time of day or night that is inappropriate for alcohol if you're watching Lindsay.
Yeah, I know. I have to go out in my big, heavy electric wheelchair in the snow later. I don't think doing that drunk is a good idea.
Oh, I have to read his.
Sorry, I like Clive Wells' last comment. It's too late for Lindsay. It's been too late for Lindsay all his life.
In his description,
I found
in his description for Lindsay, he's got Google. How does air in the tropics? Geography. And then Antarctic's climate, the key factors. Then watch my videos and tell me I didn't know what I was talking about way before these sites popped up. Note, all my knowledge came from ancient Egyptian and Christian text before I started looking into what science teaches are unexpected. Trust me, the ancients weren't talking about the bloody weather. And oh, that's the end. That just goes and. There's no continuation of the sentence.
why would it continue?
I don't know. That's his.
I was gonna say I found scotch. I hope you found some Lindsay. I just figure if I'm gonna kill some brain cells, I might as well enjoy it.
Well, you got 23 minutes and 48 seconds of brain cells to be killed.
Oh god.
I'm just waiting for the P word.
Yeah.
Oh, wait a minute, I've got to share it
Bye.
first. Wait a minute, no, I've got to share
Yeah,
it.
share
in
it
here.
first.
I've got to share it first.
That's why none of us were telling you to play because we didn't know.
Spoiler alert, the fewer times you say pause, the quicker this shit will be over
Yes, mute donkey.
with.
I'm sorry. They say things and it bothers me.
Why did I always?
Yeah.
Why did I instantly thought of you, mute donkey, when Blue said to
Because I'm the one always going, pause, stop. Oh God, why? Wrong.
We haven't got Paul here, so I mean, we should get through it a little quicker.
Okay, if you do want to pause it, keep your words less than 10.
Yep.
10 swear words or what?
Yeah. Don't worry.
Terry,
What?
Renee Me's on the Discord, isn't he?
As far as I know, he is.
And he's on the thingy to see the special place.
Renee, me go into my Discord into the special place. You should see the latest Discord, the latest Zoom link. I'm sure you've got the role for the special place. Press play. Jinx, you said press play.
Welcome to my Flat Earth site. If you haven't been there before, check out the previous videos, get to understand what we're talking about. But today, I just want to run over the Earth's magnetic fields, just to explain them a little bit more.
Did he say magnetic fields plural?
This guy runs that PV Angel channel. He's got no idea.
Well, I mean, technically,
I
we
don't
do
know.
have more than one.
I know some people have been following him. I don't understand why. The woman's voice on there, she's onto it. Listening to what she shows, she knows she's coming from the right place. But the main guy, the old fella, I don't know what he's on about when it comes to that flat Earth map. He thinks I'm a bit of a flat Earth fraud. He doesn't understand. He keeps relating this to a spinning ball globe. So I thought I'd just run over a few things just in case people don't understand. Maybe he can click on. I don't hold that much hope, but anyway. So this is how the magnetic fields work. We live on this. It's like a ring magnet, and also works the same way as a Schroeder rotor motor. You have the southern field, the northern field, both rotating, both coming together, moving westward. And that band there is the tropics. That's a very important part of Earth's design. The tropics. That's right in here, the tropics. Because the magnetic fields come out of the south and pass down through the tropics here. Come out of the north, down to the tropics.
Stop.
They go through the Earth's negative.
Stop.
Was it me this time?
I know.
No,
I was
no,
just going to
it was
say, my mouse was somewhere else, and I couldn't stop quick enough.
Since when do we have a magnetic pole at the tropics?
Since Lindsay decided one should be there.
Or actually, I suppose we should call it a magnetic circle, because it's not really a proper pole, but you know what I mean.
Mm-hmm.
Since when has the magnetic field been going down through into the Earth at the equator?
Oh, since the other Lindsay video where he showed that that's a thing because of reasons.
Dave Cannabis, look up at the whiteboard. It's a bum. It's a pair of boobs. No, it's super derp. And Dave Cannabis says, Terry, where's my seed chrome? Well, I got no idea, Dave, because I don't handle the tools in here.
Back up.
Oh,
Now, this is basically what we have, eh? There's centre north, the Arctic North. We have seawater and ice above. Way down here in the Antarctic, we have all ice above the land mass. So, this is your negative, there's your positive. Or positive here, negative, the land. And here's the land here. So basically, we'll say that's the tropics, right? So it's coming off here, off the ice, going to the lowest medium pressure medium. And this, I've only just realised this is what Ken Wheeler's been talking about all along. There's no opposites attract. They just race towards the lowest pressure medium. And there's low pressure here because the rising hot air from the tropics, the low pressure is meeting the high pressure that comes off the Antarctic and Arctic, the thin dry air. It's higher pressure, it sits here, but it gets flowing towards this low pressure medium, and the low pressure medium going up is pulling this down. It pulls the field down, otherwise how's it going to get down? There's always a counter force. Everything is duality.
Wait.
So we've got the low pressure coming up, coming out.
So air currents and air pressure push magnetic fields now?
Apparently.
Yeah. You can't debunk this, can you? Because it's just like, it truly is undebunkable.
I thought about it, and I've yet to see one of his videos where you wouldn't make yourself look like just as big an ass as he is.
I was going to say, you could easily debunk it, but it's just so far off from the truth that it's, why waste the time?
Yeah.
I mean, it'd be like me going out and saying the grass is blue.
No.
And you pointing at it and going, it's clearly not.
No, because in a lot of cultures, there's no difference between green and blue. Green and blue can be considered the same color in some cultures.
Well, that wasn't his point,
okay.
Alan.
But
the
grass is red. That would be your better.
See, I was waiting for the argument of somebody being colorblind or something. I was like, see, we're still not dumb enough to be at Lindsay level.
Oh yes, because red-green color blindness as well. But yeah, lots of reasons for the color thing. But you know, this is just, as I like to say, practically not even wrong.
Oh my God.
Renee, you're going to lurk in the background because you can't hear the video.
Are my levels bad?
No, you'd have to join Zoom to hear the video unless you're listening to it through YouTube.
Okay, I need a Zoom link. Could you give me one?
It's in the special place. You should have the roll. Are you on a phone or a computer?
He has the roll.
You're on a
I'm on a
PC.
I'm on a PC.
Right, where you are now, if you scroll down past Toons and Dags to a place it's called the Oz Squad. You see the Oz Squad
Computer.
down further?
On a
Where you
computer.
are now? Where your voice is in the chat on the side there in Discord. Do you see yourself in Have a Go Your Mug where your voice is in the voice chat? Sorry folks, technical difficulties. We'll regular scheduled program will resume shortly.
Theodore figured it out. Lindsay smoked all the grass. That's the problem.
Oh, okay, I missed that one.
Yeah, confidently incorrect. Yeah, that might be the right way to put it, Jingshu.
Boomers helping boomers with tech. Hey, Brainery, I figured it out. What shady going on about?
I
There
don't
you go.
know.
Renee, I sent you a DM with a link in it.
And see how he goes. And mute yourself and deafen yourself in Discord when you join. Alright, back to the thing.
Now the love must just disperse around here. When it comes back down into the earth. But back in here, when it comes back into here, this is the choke point in a ring magnet. This is the choke point. It all converges in here. This is magnetic convergence. This is where you get all the pressure and the sun and everything is created. It's all created in here. And here. This flows out, comes down through here. It's basically, you could draw it like this. This is the electrical
But he
circuit.
has the current
This
going
little
the
rest
other
is
way.
Down here, you got the magnetic field come out this way. Down here. It comes down here, not there. Doesn't go down the guts. There's nothing happening there. It's just like a vortex, the black hole, the vacuum, nothing going on. Then we have this system here. We've got
just-
the
He's pointing the
magnetic
wrong
field coming
direction
up.
when he said nothing's going on.
into there. So you could say this is the cold. Well, it's cold because it come up the ice.
That image is about to get really dirty if he keeps drawing.
Well, he keeps sticking
It's
his
got
finger
the
down
pressure.
there.
Cold lifting
High
the hot
pressure.
air.
Or electron, electrical. The sun is in here in the choke point.
What? Electron electrical?
This is
Yeah,
basically
yeah.
alchemy, isn't it?
Both got elected,
Yeah.
That
no?
deserves a shot.
Yeah,
Well.
okay.
Let me guess, it's the
sun in
chapter
there.
eye.
That's how it's created. It's the choke point.
That's
The
what it
pressure
is, it's
builds
the
up, the
chapter
pressure,
eye.
bang. That's where you got the sun created. The magnetic field was first. Somehow,
Somehow.
closed magnetic field.
Explain somehow. You just put the word somehow in there and go, okay, somehow.
Well, the currents are moving out from the North Pole, but apparently everything's moving into the North Pole because there's a vacuum or a
Somehow.
black hole or something. All these things that are completely different from one another, but are apparently the same thing. I just
What was that
nothing he
pressure?
says makes sense.
What would I know? I missed it. I was too busy reading the peanut gallery. He said earlier something about what magnetics causes what the air pressure.
Oh, he was saying that like where it gets pushed back down at the equator, it's because of the air pressure pushing on it or something. It's hard to understand him, but it was something like that.
Okay.
One theory could be was water. Somehow the water gets in. Maybe not. Water gets in, builds up pressure.
No,
system.
not.
I don't see how.
I'm sorry,
Anyway,
these people just crack me up.
We could have had a flood at some stage, but once the sun was created, that water rises, becomes moisture, atmospheric moisture, which lowers the sea level.
Wait.
So if we turn the sun off, down she drop. I mean,
What?
all the-
The atmospheric
Pause for a
moisture
second.
lowers the sea level.
Wait,
What?
did he just point at the North Pole area and say the sun's there? At the same place that has the vacuum and the black hole, and so now apparently the sun's also there?
Everything's in that central column, didn't you know?
And nothing.
Haven't you been paying attention all these months?
Not really. I've been drinking mostly.
No. The sun, the stars, the moon, and everything else are all in that central.
The centre of the
Column
donut.
that
The
sticks-
centre of the donut.
At the centre of the donut,
Okay.
and then they get reflected by the dome to wherever
No,
they
projected,
to
not
wherever we're supposed to
reflected, be projected.
and then reflected off the dome.
Projected.
Lindsay should write a fiction book, like either a fantasy or science fiction book, because I'm sure it would be great.
No, because he can't. He can't make shit up worth a damn, can he? I mean, you know.
I mean, he makes shit up all the time. That's all he does.
Yeah. Sorry, correction. He can't make shit up consistently.
Oh, that might be a problem. Especially
Well,
if he tries to have more than one book.
Yeah,
Sorry,
I mean,
sorry,
that's-
Demon Orb. I shouldn't have mentioned donuts.
Let's face it. He don't make shit up like, say, Tolkien makes shit up. You know. Invents a complete new mythology for northwestern Europe, and has it consistent over like 9 or 10 books.
Yeah, no, he wouldn't be any good at that. But I mean, he would create his own little world with its own rules and everything. And I mean, so there could be something interesting in there.
Yeah.
I mean, if he was talking about a fictional world and these were the fictional rules for his world, I'd be like, okay, it's a little out there, but sure. I mean, if you're making all this up, we could make it work.
Now everybody's thinking of donuts. Jeez.
Go nuts for donuts.
Yeah.
Now I kind of want to go get donuts in the morning.
Donuts.
all that atmospheric moisture drops and the flood comes back again, but I don't know.
Well, the flood comes back, atmospheric. Okay.
Yeah, that's basically how it works. What's wrong with the system? Nothing.
Everything.
Gives a chance to answer before you correct yourself.
Yeah. Actually, that was what I should have thought. Should have. Little Wolf said, "It's like Discworld, but dumb."
Okay.
Yeah, I don't like comparing him to Terry Pratchett or Tolkien. Like, I think that's just rude to those guys.
No. This is saying he's. I was negatively comparing him.
Yeah.
To those guys, because you know there is so much. They're like whether they're the equivalent of real world physics to Lindsay's version of real world physics to fiction, if you know what I mean.
Yeah. Have you ever heard of the series Pinky and the Brain, the cartoon?
What are we
I've
going to do
heard
tonight?
of it. I've heard of it.
Yeah.
Take over the world as usual.
So Brain says to Pinky in one of the episodes, "I'd compare your intelligence to a bar of soap, but I don't want to insult the bar of soap." It's kind of how I feel about Lindsay.
Yeah, exactly.
Now, I think science has been watching my channel. I'm going to lead you to a site that's never been up before. It's new. It's been explained in
hope
other
not.
ways, but not as clear as what I've been explaining here. And this site has got it all there. How does air circulate in the tropics? Geography. Check that out. Push that.
We can't see your phone.
Look what we got there. We got the brain.
Oh God.
We have the brain. Atmosphere. That's the way the magnetic fields
No.
work.
It's not talking about magnetic fields.
Go to the site, read it all, and check out my videos. It's like they've copied my videos. And look how clear that picture is. The merging magnetic fields in the tropics. You don't live on a ball. It all works like this. It all makes sense. Look at that. Sitting on top of a ball. What a joke. They haven't even got it right anyway. The fields. And then tap in all the blue words, get the Coriolis effect. You'll understand it all. It's all associated with the magnetic fields. You can't not deny it.
Hang on.
It works just like this.
How can Coriolis effect be associated with a magnetic field?
Everything's associated with everything. Haven't you figured that out yet?
Yeah, all right.
What I was yelling about 5 minutes ago. It's.
I mean, yeah, it's like it's getting worse.
Yeah, I mean, he talked more.
How the winds will go this way, but then come back this way. There's always a counter force. What's going in that way? There's a field coming back this way. That's what's pulling each other. Everything's a duality. I just read that somewhere too. I think it might be here actually. If you haven't read this book, I suggest everyone gets it. Every kid should be taught this at school. It's all here.
This guy's one accidental
No,
tap
the
away
Bible
from a
anyway.
questionable landing page.
Read this instead. We've got page 48. The unmoving nous moves matter. Thus, since the cosmos is a sphere, basically a dome, that is a head, a head, referring to the brain, because it's basically what we've got up there, the magnetic field. And there is nothing material above the head, as there is nothing mental below the feet. Where all is matter, no nous is the head. So nous is the head, and is itself moved as a sphere. That is, in a manner appropriate to a head. Therefore, all that is united to the tissue of the head is the soul, and is immortal by nature. Just as even the body is made in the soul, so all that is united to the head has far more soul than body. What is further away from the tissue of the head is mortal, having within it more body than soul. Every living thing, like the cosmos, is composed of matter and nous. But it's really deep, if you really think about everything that's written in there. Go back, read it 5 times.
Terry, you paused it. If you're talking, we can't hear you.
Sorry. Clive Wells said something out in the peanut gallery. Formally, the force equation for magnetism and Coriolis are very similar. Both are proportional to the cross product with the velocity. Can somebody explain that? Besides Clive?
Yeah, basically, the way you apply a magnetic force is very similar to the way the Coriolis force works, and cross product is like a fancy thing for vectors.
Oh,
And,
okay, vectors. Yeah, okay.
and unfortunately, I managed to wing my way through the maths 25 years ago when I got my degree. So I'm not that good at it anymore.
Well, it's just another vector.
Yeah.
Yeah.
Cross
Yeah.
product of two vectors is another vector which is perpendicular to the two you started with.
Yeah, and they're both related to velocity.
I understand vectors, Victor.
Yeah.
Well, what's your vector, Victor?
Coriolis is the cross product of the rotation vector and the velocity vector of the object that's moving.
There's a question here. What then is material? God. Hermes says, the cosmos. Beautiful but not good, for it is material and easily affected. And although it is the first among things that change, it is second among things that are, and it is...
Who's this herpes guy that he's reading a book from? I mean
Hermes,
Hermes.
I
I
think?
mean Hermes, sorry.
It's a Greek god. I think that's the reference that it's trying to be.
So it's just mythology. That somebody...
Yeah, Hermes is the Greek god of is like the messenger god.
So this is written from ancient text or ancient writings or something from Roman Greek mythologies?
From the sounds of it, it looks like somebody took the name just as a reference point or whatever and is writing some new age pseudo nonsense.
Okay.
But I don't know that book in particular.
Okay.
complete. What it's basically telling you is the human brain is connected to the cosmos. We can affect it. So that was that. And let's just... So we have the... Okay, so we have this coming down, dot, 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 dot.
He's lost. He doesn't know where he's at. He's lost his place.
It comes through the earth and then back up there. It cuts across there and back up there. Through the ice. Comes through the ice. Starts flowing through the ice. The ice, the seawater does something, changes it. But anyway, just saw one of Santos' old movies. He says everything spirals and vortexes, and he's right. And this is what it is, because this, if you follow these curves, wasn't it Edmund Halley who discovered these magnetic curve lines? And you read that site and find all the garbage they start talking about. It's just the magnetic field lines. I think they've got 11-degree arcs. But it's a spiral, like this. Will come over positive, down opposite direction, negative. And it works. So, you know, they don't close circuit, whether it's just a magnetic field or what, but it's closed in. And this is what's going on. Now, another thing, on one of my previous videos, I showed the V. Like this, and the sun down here, and the moon on the outside, and the planets up here, right? 5 planets, 2 down here going around, and Mercury and Venus standing around the sun. But, you know, it's back in here.
Mute yourself in Discord, Renee.
I completely ignored my theory about things, what go out, come down in our world. It's down and out theory. And what
Little
comes
wolf in the chat.
goes up in our realm. We're not seeing anything in here, we're not seeing this. So I've obviously got that upside down. And it all started making sense once you put it up the other way. Like this. Because you've got this set up, haven't you? And the sun is in here. It's the choke point. And all this turning over the day, over 24 hours. That's sun. So you basically got your, say your V's over here like this. And the planet, you got maybe Venus, Mercury, Venus, Mars, Jupiter, Saturn. Like this.
Might have to deafen yourself
The
in there
moon's
too,
out here.
Renee, so you don't get echo.
Because these are all magnetic. They're electrons. It's electric up here. That's the proton. These are the electrons. And this moon does this. The full moon. And then one's back to the sun again. It's a new moon.
A little bit
Down
messy
as
there.
it comes down and out. We see the moon go out as it gets bigger. In our realm,
It's
don't we?
clear. It's perfectly
One's
obvious.
back in.
Can't
So
can't
this
you
is where
tell?
You get the
Oh, sorry, Mike.
Fibonacci sequence, or the golden ratio. And this is what I had in
Oh
the earlier
my
videos
God.
about the moon cycle. It's basically doing that. Because it's starting off narrow and getting wider as it comes out, right?
Choke point, there's an
So it
idea.
works. And obviously it has to come back in again. So this is just the shape you use without getting too complicated, but it comes in handy when you
Oh,
Oh,
discussing
really?
with logical
Really?
rules,
Get too
just the
complicated?
Phases.
we wouldn't want him to get too complicated.
No.
Spacings and all that. Tesla's
Now on
369s.
mute. On,
But
Discord.
Oh yeah, I
it's a
just
monthly
server
thing, but
muted you
during the
indefinitely
day,
over there.
On a daily basis, you've got the black hole to contend with that's going around the black hole. This is the black hole vacuum.
Oh God. Oh.
So, you know, this is just all expanded
Doesn't
right
know what a
out.
black
It's all
hole or a
closed up in
vacuum
the
is.
system. The moon is flying around in here. It's in the around the black hole. Everything goes around the black hole. You exploded all the black holes like this, and the sun's
Okay.
here like this, and the moon's traveling around here. But the
Don't throw me into
but
a
the sun's
brain
going
seizure
quicker.
there, Jerry. Please.
See where you're going. The sun's going quicker. It's the sun that catches up to the moon.
You'll be right, Mike.
So it's going around this black hole all the time. So on a daily basis, it's basically doing this, isn't it?
Nice one, Jinx.
Yeah.
And
Come
around
on, Jim.
there,
Yeah, I'm not reading it out.
and around there,
Neither am I.
and around there,
Oh
around
God.
there, but more condensed. So basically, it's
These
just going
peanuts are disgraceful.
like this all the time, isn't it?
Sir, the little wolf, it might very
Back
well
in
be.
again. Some scientists
I tell you
couldn't
what,
figure
it's a
that
good
out.
job I'm not
Pulling that out.
monetised, isn't it? Because
Yeah.
this has never stayed
Don't think too
monetised.
well.
Oh, there's Jay out there. Long time no see, Jay.
They live on a spinning ball.
Oh,
What else can I say? But I was blown away with that site. It's just all there. It's like they've been watching my videos. So check it out. And I guess I'll have to leave it at that. Just remember. And when you go to that site, just keep this in mind. A ring magnet. There's the choke point. It has to flow into that ring, that choke point.
This guy and his
That's what creates all
whiteboard.
the stuff in
Oh
here.
my God.
That is the tree of life, all in there. It's all hidden
All
in there.
over the
You
place.
cannot see it.
Now it's
Nothing
the
out
tree
there.
of
It's all
life.
wide open. And then you can understand why Antarctica is colder than the Arctic. It's got more area to cover to get back into the tropics when you don't need so much energy in here to get to the tropics. Look how tight and small it is. It's just nature again. Colder,
You draw him.
slightly weaker to marry in to meet at the tropics. And also on that site, you go on other sites like airline flights and the turbulence at the equator. They mention 10 degrees, and I said in the earlier videos, it's not 10 degrees because I go to Samoa, that's 13 degrees, and you hit them before you get to Samoa, 13 degrees south. So what I was thinking was, you know, there's your tropics. It'll be coming down the outside. This field here will be coming
On the
down the
outside?
outside, and you'll be having the tropic zone
On the outside.
coming up coming up like this.
What?
Sure enough.
What?
This is 23.5, right? Or 4
Okay.
or 5. Now they're saying on that site
Okay.
this is 30 degrees,
But
which is probably
but
right.
hang on, stop,
Because that's
stop,
where the
stop,
pyramids
stop.
are.
Zip, no way.
Testing you all
Yeah,
about
yeah,
it, son.
yeah. Stop.
How can you have degrees of anything on a flat plane? Where are you measuring this angle from, Lindsay?
I mean, it could be degrees from the ground to the sky. I mean, you could still have degrees on a flat plane.
Yeah, but I mean, how do you have a grid on a flat plane that is measured in degrees?
Are you sure Lindsay's not talking about Celsius?
Yeah, that's what I was thinking. He might have been talking about temperature.
Who knows what he's talking about?
Well, if he's confused about temperature, he'd probably be talking in freedom units, not real ones.
I wouldn't be surprised if he had his own units, to be honest.
He should be in a unit, a psychiatric unit.
These are the Lindsay units. Somebody needs to take
Didn't they?
away his marker.
And he was building his an energy tower. He knows the magic goes on around here and here. And both sides of the tropics usually where you get your desert areas.
Hang on, isn't he now
Yeah.
drawing the tropics sort of
And
about
there's another
halfway
side
between
here.
between his
Yeah.
equator and his South Pole, outer rim?
Yeah.
Well, the equator's in the middle there, so the tropics.
Because he's got the Arctic right over on the left,
Mhm.
and then he's got his right hand side is of the thing with the equator.
This guy
in the
has
middle
a
of it.
fascination. What is up with the butt diagram and the anus diagram? I mean, what is this? This guy has a fascination with butt.
And boobs.
Back one.
Go on then, Terry.
This Antarctica's climate.
Behave,
key
little wolf.
factors, discovering Antarctica. And check all
I'm not
that
reading.
Out. Yeah, I'm not going to be talking about magnetic fields. It's just solar winds and all that, but it's all connected. What do you think the solar winds are carrying? It's all supporting each other. One thing's going that way, one's going that way, and they're all supporting each other. That's how everything works. Everything's
But I
a
thought
duality.
the sun was in the flipping middle. How can the solar winds come from the
Yes,
outside
I've done
edge?
that. You can scribble that out. But
It's around the outside.
Quantum jump. This is physics for you.
This
Not understanding quantum jump.
Oh, yeah, rub it all out.
It's so
Start again.
simple. Imagine these quantum jump. Let's say that's a planet.
I don't think you should say
Here's the
rub it
sun.
out, Terry, after everything else that's been going on in the
Moving
side
around the
chat.
cosmic egg.
Oh, sorry.
Here comes the sun. Oh. Sun moves away because the sun's quicker.
This guy is hilarious.
So we've got it there 1 minute. So there it is here 1 minute. Sun comes along. Sun moves off. Oh, it's there. It's gone from there to there. They call that quantum jump. Woo! Can't figure that out because they've got all the cycles wrong.
We've definitely got to
hang on.
see if we can get
Wait.
McToon or Team Skeptic or somebody to interview him, because he won't come on my channel because my channel's too small, he reckons. He'll talk to somebody on a bigger channel, I reckon.
Toon would be the perfect person, or Creaky Blinder maybe. You know, like agree to disagree.
Yeah.
No, Toon would be the perfect person for him to talk to because Toon has enough knowledge to be able to wipe the floor with him.
Yeah.
Oh yeah. Well, and Toon has that perfect way of
Yeah,
being nice and
agree.
absolutely still destroying somebody.
Yeah,
Yeah, two would mop the floor with this guy.
Also, I want to say the fact that you have to add specific amounts of energy to an electron to make it go from one orbital to another is not a problem and is very well understood. That's it.
Antimatter is a dual system. We call this matter antimatter or matter antimatter. It's the electrical circuit, magnetic vortex. Science, they don't know. You've got the cosmological constant. That's always energy coming out of here. You've got singularity, the point in here. Like Tesla said, points to the Milky Way. You can shrink that all back to something the size of an apple. That's what people can't get their heads around. That's what they have to get their heads around to understand this whole flat earth model. It's all right back here. It could be as big as this, and it's just amplified. We just live in a blown up, amplified realm of energy, and it's all based on consciousness.
It's all based on
It's
consciousness.
all created in here.
Okay.
Because
I
there's
made it up.
systems of
We're
brain
going into that realm.
coming out of the eye of brain.
It's all about
memory.
consciousness.
Will it be a memory? A fond memory and gain eternal life? Will be a nightmare and recycle and redo it all again. Because all your energy goes back down through here to be recycled to start all over again.
I'm a light worker.
So we've got the cosmological constant. I don't know what the hell that's what's going on there. That's constantly going out, but it's being recycled, coming out to there, going down to the earth. It's all being recycled back in again. Out, down, back up again to be recycled. It's always being amplified out. All the frequencies come out of that zone.
It all makes sense now. Thanks, Lindsay. That's what I needed.
Triangles. You got this thing here too, haven't you? You got the sun in there. You got all this going on. It's your magnetic field, but it's all crammed into, say, an apple size in here. All coming out.
It's the size of an apple.
I mean, even the
And
shape
it's got
here.
the sun in it.
It's just a speaker, like a speaker.
And a black hole.
Everything just comes
And,
out like
and-
that.
and all the stars.
All frequencies.
And the planets and
Frequencies.
and
Something
the
alike.
vacuum.
Electromagnetism, magnetism, electricity, electromagnetism into our realm. What else they got? Then blue shift to red shift. There was another. What was it?
Yeah, what? Blue shift to red shift. That's got
Right.
nothing.
Yeah, I was going to say,
I'll leave
where
it
does
there.
blue shift, red shift come into that?
Look,
Oh,
nothing
okay.
he says makes any sense
Oh, and then
or
it just cuts off.
Then
like
he just
usual,
walked.
'cause
Yeah, then it,
the
yeah.
camera runs. Or did he walk out?
No, I think he walked off.
I thought it just died.
Lindsay
he started to
Moonlight
walk off and it died. But
Lindsay,
I think that one lasted a few seconds longer because that one's 23:48. Doesn't it normally end at 23:17? Did he get a bigger memory card?
I don't know. He's got a few seconds over here.
This guy is a prime example of dim-wittery. Is exactly.
The Blue said Lindsay moonlights as a donut chef / proctologist.
Dunning and Kruger would have had a field day with him. Let's just leave it at
no
that.
doubt, no doubt.
You know, we were just suggesting that people could be this dumb. We didn't actually think that.
Well, like Blue says in his quote, Blue. Sorry.
What?
I said, look, what Donkey said something about just then. What did you just say, Donkey? Something about being stupid?
Oh wait, yeah, we were just theorizing that people could be this dumb. not the we weren't saying that you had to be or something like that.
Yeah, and then I said blue. What is it actually the saying?
Oh, I see. You queued me up, didn't you? Yeah, well, when we say how stupid can you be, that's not a challenge. That's a question.
Right.
Good one, Blue.
Okay.
Oh, now Mix corrected me. It's 27:13 is his max. So he ended it a little short. And Clover Mom, I don't think that's a good idea. I mean, with what he draws already, I just don't want to imagine what his OnlyFans would be like.
Some people shouldn't own a whiteboard. This guy is one of them.
Some people shouldn't own a camera.
Or an iPhone.
Remember, YouTube responsibly.
Okay, so how far we're back? We've got to catch up for Lindsay. Oh shit. Okay, so that's that one. We've still got about 9, 12. Oh shit, we're way behind. That was a month ago. That one. The next two he's got run at 5-7 minutes.
Oh, those are nice and short.
And then the next one after that is back to Rahu and Ketu, the Legend of Reality. The two short ones is why 365 days on a 360-degree sphere.
Ooh, I actually want to hear his explanation for that. I mean, I know it's going to be dumb, but I really want to hear it.
So, do you just want a Lindsay quickie or not?
Lindsay Quickie.
Oh,
Dumb
well, to
is
go
fun.
one.
Dumb is fun sometimes.
Should have a vote on it.
Okay, I'm putting a vote out to the peanuts. Do you just want a 5-minute and 34-second Lindsay to finish Lindsay off for the day? Because we've got to slowly catch up a little bit. Because we're not going to be showing him every week. Because I won't be.
Okay.
I'm not sure when we're going to be streaming again. Little Wolf says yes. Get 3 yeses and we'll play it.
Yes.
Go for it. Is that like a Lindsay Rich? What? Oh,
You said Lindsay Quickie.
May as well, why not?
Oh dear. These guys are terrible, I
Suck.
tell you. You just want to be tortured, I can tell.
I mean-
Took a shower.
You know, in for a penny, in for a pound.
Yeah, push your monitors back. Again. Oh, what happened to Alan? He got dropped out and he came back.
I don't know where he went.
Yeah, he went and then
Alan is
he
AWOL.
came back.
Alan is AWOL. Oh, there he is.
He's back again.
I'm back.
Yeah, well, I don't really need Alan. I can do the show without him.
Right.
I should have had Bob in the meter again.
Oh, no.
Sorted now, though.
It's all sorted. Oh, well, you're back for more Lindsay then.
Damn, I thought I got out of it.
Yeah, well, 5 minutes. We should be able to play this right through without even a pause.
Play.
What, you mean
Play.
just talk over it?
Challenge.
Welcome to my fabulous site. Today might not be, well, it's all connected, but anyway, I was just wondering, do many people think why we have 365 days on a 360 degree circle or a ball? And how do you get these extra 5 days? Well, if you go back to Egyptian mythology, Thoth played this game and won 5 days and gave them to the moon. And if you get right into the myths and flat earth, you get to understand that all the cycles all go back to the moon. All the numbers we have, like the Great Precessional.
Yeah, but 365 does not divide into the moon cycle evenly.
No.
Monthly cycles, all those numbers all add up to the moon cycles. What the moon is
It's
doing.
just
all these
complete and
numbers.
utter
3,
bollocks.
you know, the golden
Yes.
ratio.
I wish I could say
pi and all those,
with
all
the same
associated,
emphasis that
associated with the
Cool
moon.
Hard Logic says it, but yeah.
Anyway,
Yeah.
basically what it is you lose 5 days at the equinox.
Yes, Carl, he did.
That's when it's all level like this. It's the story of Jesus on the cross. He's level. Because a special time happens in spring. You know, sun goes aphelion,
The number of
perihelion.
degrees in a
Well,
circle
it's not
is down
going
to
up
the
and it's
fact
not
that
going
the
down, so it's not going anywhere.
Babylonians
So you're
used
not getting
base
extra days
60
put
for a
on
lot of stuff.
the ball or
Well,
the circle.
It's also we still
not
use it
down.
because 60
Up or
is a
down.
great number because
It's
it has a
level.
lot of numbers that divide into it, so it's easy to divide into smaller segments
Yes.
for a lot of things, and so that's why we like numbers like 60 and 360 and stuff like that. 12. That's why we use these numbers for a lot of our counting
Yeah.
system.
Yeah. And unfortunately, 360 gets all
So
divided
you're
into.
losing 2.5 days here in the autumn, in the September spring, and 2.5 days here in the March spring. So that's the 5 days. And that's also associated
September,
with
spring
5
and March
holy
spring?
days where the moon's allowed to give birth.
Does he not mean
in the Thoth
equinox?
Story. And this is the
He keeps
divine
saying we lose
awakening
5
period
days, and I'm
of
still
a man's
confused.
Enlightenment.
Because wouldn't we be
in
gaining 5
spring.
days?
But it has to be a full moon at the same time as Earth's magnetic field is at its strongest, which is between 3 and 3:30, right? And that full moon, it follows a full solar
Clive,
eclipse.
yes, he uses radians.
Maybe you get partials that do a partial thing, I don't know. But the big ones are following a full solar eclipse, and the these 5 holy days are in association with the 5 planets, the 5 main planets: Mercury, Venus, Mars, Jupiter, Saturn, because those planets are connected with the solar eclipses.
Wait,
It's
what?
It's not the flipping moon going crossing the ecliptic or whatever. No, it's not that. It's 5 planets are involved because that's one of the trinities. There's 3 trinities. That's one of them. You've got to have the sun, which is the extra planet. You got the mother, the
Look,
father,
the
and
only
the son.
trilogy in 5 parts that I
You got
know
the
has
mother,
nothing
which
to
is
do
the
about
moon.
those
The
planets.
sun is the father, and the son, the child, is the planet, the extra planet.
What?
And this is how it goes. We know the planet, the Jesus story was the Pisces. The full moon was in Pisces. Oh no, that was just that was separate. No, that's the zodiac sign. Yeah, that's where the moon was in that. But the planet that was in there, you could have had several planets, but there was Jupiter in there at the time. Because I refer all this back to the 2017 solar eclipse and what happened after that, and it all apparently added up to be the same story as the Jesus thing. You know, all those planets lined up,
What?
12 crowns above your head, and Virgo and all that, and Jupiter going between our legs and whatever. So it's Jupiter and Mercury and a couple of other planets. But it's to do with those 5 planets lining up. That's what I put it down to. You got the 5 planets and the 5 holy days. And on those 5 holy days in Egyptian times, they had the 5 deities. It was Isis, Osiris, Seth, Nefertiti, and Horus. And they all represent a planet.
Pisces wasn't an Egyptian god, was it?
There's my
No.
good friend, Professor Phil Bill.
Those are 5 extra days.
Chat.
Yeah,
Over
I think we noticed.
over a
Hello, Phil.
360-degree
Good to
circle.
see you.
Get it?
Oh,
I mean, thank God it was short. Because none of that made any sense.
yeah.
I still
Like
couldn't see.
not that he normally makes sense, but God.
I couldn't see the correlation he was trying to make between the 360 and 365 days.
There isn't any.
Oh,
That's the problem.
I couldn't follow anything that he was trying to say. I mean, like, worse than normal. Because he started talking about, like, Egyptian myths and stuff, but he was doing a poor version of those as well.
I'll say bye to Lindsay for now.
Good.
Carl said you broke us. Oh dear. I think we need a change of pace.
5 makes the Trinity, apparently.
Need a pacemaker.
Okay.
Nice one, Professor Phil Bill. He's commented to me about Jupiter. It's like it's an inside joke. Nobody gets it. We do.
Apparently, Little Wolf, when you condense Lindsay, you condense all the dumb, and you apparently filter out all the whatever else is filling in the dumb, because I don't know.
It's so derpy, it wasn't even derp anymore.
It's gone
Yes.
beyond derp.
Yes, Phil, I'm back in jail again. My fault this time. Okay.
Maybe Carl Edwards. Sounds about
So,
right.
Peanuts, do you just want Simon Dan or Mr. Sensible with Simon Dan, Flat Earth and Money? Or
Oh, the Mr. Sensible one's really good.
Everett Anderson, Flat Earth Water is Fake.
Definitely want the effort, Anderson.
Isaac Butterfield, the Australian neighbour from hell.
I was going to say, are you trying to get out of us having some, looking at some MC Toon debate and having a good laugh at,
You
The
would,
bearded
if you'd have
one.
let me finish, Alan.
If you would have let me finish, Alan.
Yeah, apparently there is a Mr. Sensible and Arwen debate as well.
And we got Where's Wally? Oh, so- okay. Somebody had to repeat that.
Well, yeah, we need to loop that.
Or we've got McToon with Wayne Chipman. Now you can speak, Alan.
Toon with Wayne Shipman.
Steve.
Alan.
Was that Alan?
Alan.
Well, it goes for 2 hours, so if anyone's seen it at all, to help with the...
Yeah, we can skip around it a bit.
Yeah, the first bit is quite good with his.
So play the introduction, a little bit into it, and then we'll do a skip.
Yeah, just kind of go to the first bit of the thing.
Okay.
I have.
There we go.
You're also not showing it.
I know that donkey.
You're showing it to them.
I know that donkey.
But just double checking.
With me, connected, but not visible. He doesn't have his camera going.
You can skip a bit because
I
it takes
have
him a
Wayne
minute to
Shipman.
connect.
How are you doing, Wayne?
Real great.
Good. All right. Your audio looks good. Your video is what it is. I'll get something in place for your video, or so people can see you.
You can put that one picture up with me on the other one I did with the beard and all that. That's fine.
All right.
I look goofy enough.
Yeah, that's if you say so. I'll let you stick with that one. All right. So why don't you? I got to do a little moving things around. How about you talk a little bit about yourself here for a minute?
I grew up in Vancouver, Washington, one of 6 kids. My grandparents had a 160-acre farm in La Center. I loved it, loved that life. And then I just kind of, went along with my life, didn't pay much attention to anything, just work, raise a family and all that. Then probably 15 years, maybe a little more ago, I talking to an old Vietnam vet, and he told me the truth about money. And I walked away thinking that guy's effing loony bins. He's a nutcase, but he piqued my curiosity. And then for probably a year or so, I spent studying the creation of money, our history of money and all that. It's a rabbit hole that goes endless. And then probably about a dozen years ago, I ran across a really lame video. There was hardly anything on YouTube at that time or anything about it. And it was about the flat earth. And I started studying it that night. It piqued my curiosity. And by that evening, I knew our earth didn't spin. But it took me probably over the next year and a half before I realized that we live on a flat, motionless plane. Because back then, there was hardly any info. It's I was digging for info while Eric Dubé was, as he was writing his book. And he was always a step ahead of me. But we kind of piqued each other's interest and curiosity through a bit there. And it was a fun learning experience. And it didn't really, some people say it really changes our worldview, this and that. As if I had already discovered so much of our history by this point that it was just one more turn of the gears or whatever. It wasn't no big deal. And then after that, started joining groups. And back then it was lonely. And but over time, more and more people joined and started learning of the truth. And it's been a fun ride. And I might be a little rusty right now because for probably the last 8 or 9 months, I've just been going down the rabbit hole of the current politics and satanic pedophiles that control our world, and haven't been paying too much attention to any new things coming out of the flat earth realm for a while.
Well, I can tell you, you didn't miss anything. There's no new science for flat earth. So yeah, you didn't miss anything.
Yeah.
Really, honestly, for the last 5 years, there's nothing. Actually, since Robotham, there's nothing new. So you didn't miss anything.
There's little things along the way, but he put out a lot of good points. And then there was another lady. Oh, God, I'm trying to remember her name.
Blunt.
Yes. She was pretty good, too, on what she put out.
Yeah, she had the blunts. Probably spliffs, too, I suppose. I don't know what's what. So, all right, so you said the Earth doesn't spin. How did you measure that?
Well, airplanes would probably be one of the best proofs that our Earth is not spinning. Say you're at a air show, and planes are spiraling up in the air, turning every which way, banking, looping, going north, south, east, and west. Okay, I'll give you guys relative motion. I'll give you the spinning ball, but you got to keep in mind that once this plane's left the air and made multiple turns and everything, all the while beneath it, the ground is moving at 800 miles an hour due east in America. The people on the ground are moving 800 miles due east in actual land movement. Okay, so how can relative motion keep this plane going steadily 800 miles an hour east to stay over this moving land beneath it once it's made all sorts of different turns, air brakes, you name it, back and forth, spiraling in the air, yet it always stays above the cloud just as if the cloud were motionless below it.
These people.
Okay.
Yeah.
That's.
Are you now? I teach. We homeschool our kids, and I'm the science teacher, so I know different levels of what thing are taught for science. So in elementary school, we teach conservation of momentum. So are you aware of conservation of momentum?
Yes.
Okay. Well, then that's your explanation there. That's pretty easy.
Get.
Good. Let's move on then.
Well, let's not shy that off. If the plane is accelerating east, okay, and say we have conservation of momentum and it's going 800 miles an hour due east to that, then it's going 400 miles an hour on top of that faster if it's a 400 mile an hour airplane, which a lot of these Red Bull planes are. Okay, but when it comes back,
hang on,
it's going against that conservation of momentum.
Stop just a second. If he's talking about the Red Bull air races, most of the aircraft that are in that are probably topping out about 200 miles an hour.
But that's it?
Yeah, I mean, they're piston-engined aircraft. I mean, they're small and they're very light, and they've got, several hundred horsepower.
Okay. So they're not proper jets.
They're not jet aircraft.
No.
The Red Bull air races. They're those little aerobatic aircraft. They're exactly the same aircraft they use in the.
Yeah, they're built for their aerodynamics variability to do their stunts and that with. So they've got the power, they just haven't got the speed.
Yeah. Right. That makes sense.
Yeah, I mean, and they're also rated to like plus and minus 8G. As usable G-forces, so then you have to do an awful lot to them to make them break up.
And so when it turns again, how can it still retain this 800 miles an hour movement when it's already went against it? It's like it can't.
Well, that's easy. So it goes one direction. It's going a total of 1,200 miles an hour in one direction in this this whatever latitude this would be, and then it turns. Let's just imagine it's going to stop, decelerate, and then re-accelerate the other direction, right? So it will decelerate in its reference frame from relative to the ground or relative to airspeed, really, from 400 miles an hour to 0 miles an hour. And the lateral speed is now just 800. Then it accelerates the other direction. So you need the deceleration and then the acceleration. So you went from 0 airspeed / 800 linear speed to 400 airspeed / 400 linear speed. This is all just, taught in elementary school.
I know it's taught, but in the real world, it would not play out that way.
How does that not work?
Because once it's left the ground and no longer having contact with the moving Earth, and it makes various turns and thrusts and moves, it no longer has that conservation of momentum that it had when it left the ground. It's been negated by thrust and angles and vectors and everything you want to call flying.
Pause for a second. Yeah, but any of those changes in speed that it's doing or turns or whatever, are vectors that are added onto the initial vector. So if it gains speed or loses speed or changes direction, like all that's being applied to the initial vector. It's not like that just magically disappears.
Yeah, and also, of course, the aircraft is still part of the atmosphere.
Right.
The atmosphere is also traveling at the same speed as the surface of the ground.
Right.
And they wouldn't be able to step outside.
Yeah, and it's held aloft by the atmosphere. It's not like it's being pushed against it like, people talk about dropping a ball outside of a car. Yeah, but when you do that, the ball isn't designed to pick up on the wind currents and stuff. Planes have to be strapped down because they're literally, like, especially small planes, because they're literally built that if you get a big enough gust of wind, they'll fly off into the air.
Yeah, I was actually watching a bit of video the other day of Supermarine sea fires launching from an aircraft carrier, and the aircraft carrier plus the airstream coming from the propeller over the tailplane was enough that literally they wound it up to full speed, let go of the brakes, and the tail came up because there was that much airflow going over it. It's stuff like aircraft get blown away all the time.
So thrust cancels conservation of momentum?
Yeah.
It makes the law of conservation of momentum not happen anymore?
If the plane is thrusting back at you going due west, or due east, and it's thrusting back at you, it's taken away that conservation of momentum it had on the ground. And then when it turns and goes the other way, how does it pick up that conservation of momentum?
It accelerates again.
It
because the plane has an engine. That's how.
Yeah, but we're forgetting that the ground is in a constant moving at 800 miles an hour according to spinning ball Earth theory.
And so is the air. So it's in a reference frame. The reference frame is moving at 800 miles an hour. So you don't need to do anything. Actually, you don't even have to worry about it because you're within the reference frame.
Okay. So once this plane's performed a bunch of maneuvers, the only thing keeping it going with the 800 mile an hour land beneath it is the 800 mile an hour air.
Yes. Yep. All right. You got it.
Okay.
Good.
Right. There you go.
Well, planes, if they're in 800 mile an hour air, it would do some serious problems for them when they're turned sideways to it or banked to it.
But it's moving with the air. The air and the plane are moving together. They're in the same reference frame. Now, reference frames are not necessarily taught in elementary school, maybe in high school, but it's not really that difficult of a concept, right? Have you seen people like throw a paper airplane while inside of a bus that's moving?
They're inside a bus,
or maybe play catch. Yeah, and so that's their reference frame. They're within the bus and the air together form the reference frame, and they're moving within that reference frame.
Inside it, yes, they're attached to the bus.
Sure, yes, they're inside the
plane.
bus.
Yes, the plane, once it's left the ground, is no longer attached to the ground in any way, shape, or form.
Yeah, it's in the air.
It really
and the air
would help
is moving
if you listen
with
to what
the
Tim
ground.
said.
The air and the air together are the reference frame.
Well,
But flat earthers don't listen.
He's missing the analogy between the ground and the air on Earth to the bus with its air inside the bus moving in with the surface
throwing
of the
a paper plane.
Yeah, throwing the paper plane. Yeah.
Yes, but that 800 mile an hour air that's traveling with the ground is the issue for a plane to fly in 800 mile an hour, because once it's made some turns and pressed in different positions, it's lost all of that conservation momentum. Its forward taking off speed has been negated numerous times by all its turns.
So if it's going 0 when it starts, right? Because we can just ignore, because it's in a reference frame, we can ignore the 800 miles an hour. It's in a reference frame. We don't need to worry about that anymore. And I think what you're doing is you're trying to add back in the reference frame when you don't need to.
Well, the reference frame then is basically saying we're going to treat it like everything is sitting still.
And
'cause it's
that's
all moving
exactly,
together.
yeah, you got it. That's what a reference frame does.
And you don't see how silly that sounds when we're talking about 800-mile-an-hour air above 800-mile-an-hour ground.
I don't know why that's right.
To treat it like it's sitting still because it's a frame of reference.
Yeah, that's exactly right. That's how it works. Yes,
If that 800 is applied to everything, yes, it makes the math
60
easier.
miles an hour relative to the ground, but inside the bus, you're stationary when you're sitting there. And when you throw a ball across the aisle, or you throw a paper airplane, or you fire up a
Should try to confuse him by saying 800 mile an hour wind blowing when the plane goes to take off.
No. See, wind would be different.
I know, that's what I'm saying. Try to confuse him even more. There's a cyclone when the plane goes to take off.
it all just sits there.
You're inside and then
Yes, exactly. Yeah, you're inside the bus.
touching it, connected to it.
Yeah, but the drone isn't. If the drone is just hovering inside the bus, it's
But
not.
it's a block of air that's moving inside a closed environment.
Absolutely, you got it.
Yeah,
You
exactly,
understand it.
yeah.
Good.
Yeah.
Good. That's how reference frames work.
Yeah.
So awesome. We solved that for you.
Right, now move
Okay,
on.
we can go on to another one. That was pretty humorous.
That's right. To shut the door.
It cracks me up.
We got it. All right. So then you
this
said it.
thing.
It's flat,
He's like so smooth.
Well, he's really well researched too, which is what makes it so good. Oh yeah, he does a bit of stuff in Python to calculate some angles.
Angles
This
that,
is Toons doing this here.
that's
Yeah.
Toons doing that there. That's Horizon Drop. Yeah, that's Horizon
Yeah,
Drop.
yeah.
Okay.
And
So
That's
just-
right, because the bearded one said that he got an 8-foot carpenter's level, and he couldn't see any drop to the horizon when he was 43 feet above the sea. By sighting along the top of a leveled 8-foot builder's level.
And that builder's level, has to be perfect because
You know how much degrees
reasons.
of accuracy a builder's level's got, where the bubble's actually inside its little thing where the lines are? You can lift it up. You can put bits of paper or a bit of cardboard either end of it, and lift it up at either end, and you can still be basically level if you're doing buildings and stuff. But it's not perfectly level. You'd need a better instrument than a builder's level for level.
They're pretty good. But
actually like measure or anything then.
There would have to be a drop.
That would make sense then. That's why
There
you're-
would have to be a drop on a ball. Though.
Absolutely. And so now it makes sense why you were confused, because you didn't actually do the math. So, all right, let me, let's see here. I think I have.
Did he already mention about his spirit level?
I have a couple.
yeah.
Yeah.
Oh, I didn't want to miss that.
Is the issue for a plane to fly in 800 mile an hour.
That's exactly right. That's how it works. Because in a bus, if you're going 60 miles an hour, when you're sitting there playing, or you sits there
You're inside and into it.
Yeah, but the drone isn't. If
It's at a closed environment.
absolutely, you got it. You understand now. Good.
Exactly at the top of that level,
From
which would not be possible on a ball.
from how high?
45 feet above the ground, which at 3 miles, well, I don't know how many miles the ocean surface would disappear again.
Okay, so I'll write this down. 45 feet.
Above the ground.
All right, you're 45 feet elevation. All right, you keep talking. I'll pull up, because I'm sure you did the math too. But we can compare the math. But you maybe talk about how you calculated the predicted drop for the globe and the predicted drop for a flat Earth. So just a second.
The predictive drop from a level line of sight is 8 inches per mile squared, which works out to the circumference of the Earth and math. There's charts that show it. I've got them buried in my memes
For my
somewhere.
squared.
But,
No.
So yeah. So how many How many degrees drop would you expect then from 45 feet elevation? How many degrees drop would you expect?
Over short distances, 8 inches per mile
I
squared.
haven't
Okay.
worked out the degree
Long
drop. It'd
distances,
be
no.
Oh, so you didn't
But
actually
that-
like measure anything then?
there would have to be a drop.
That would make sense then. That's why
There
you're-
would have to be a drop on a ball.
Absolutely. And that, so now it makes sense why you were confused, because you didn't actually do the math. So, all right, let me, let's see here. I think I have,
Okay.
let's try this one here. I have a couple programs. Are you familiar with writing software in Python?
No.
No. Okay. Well, that's okay. I am. And I have a little program I wrote in, there it is. All right. In Python. So let me, I will pull this up so that everybody can see it. Everybody can look. I'll share it to you so you can see. Right. This will be good. Don't worry. The Python is not very complex. I keep it pretty simple. And it just looks like a little bit of math homework is about it. So there we go. There's that. So everybody sees that. I need to fix the screen. It's a little bit too big. It's drawn off the screen. Ooh, how's that looking, people? There it is. All right, so now you're not seeing it yet. I'll get it so you can see it. Where did Zoom go? This will be cool. I wrote this quite a while ago, and I've not yet had a chance to use it. So you're the first one, Wayne. There you go. All right, do you see that?
I can't get your screen to grow after I went through so many things with the sign in. I'll take your word for what it says on the degree.
Okay. All right. Well,
yeah.
All right. So I'm going to do this. Now height of observer, is this in, this is in meters.
So 15 meters.
Okay. 15 meters.
And about 500 miles or 500 meters, sorry, from the shoreline where the actual waves hit the sand.
Yeah, well, that doesn't matter too much unless that's closer than the horizon, which it would not be. So, all right, so we've got the distance to the horizon, 13,800 meters, or 8.5, a little over 8.5 miles from that elevation, and the horizon dip, 0.125, 124.2. So, and then of course,
a little over 1.25 degrees.
No, 0.12 degrees, less than
a tenth of a degree.
Less than an eighth of a degree. Yeah, just over a tenth of a degree. So, is the precision of your measuring instrument more or less than 0.12 degrees?
That's a tough one to call. It's a pretty good 8-foot level.
I think an 8-foot level probably is accurate to maybe half a degree. And then,
that'd be probably a fair assumption.
Yeah, so your margin of error is significantly larger than the expected dip. So that measurement isn't really very.
That's what
it's a pretty good 8-foot level.
There are better instruments.
That's what I was saying about a spirit level. The amount of difference it could be just by putting a piece of cardboard under either end of it for the amount of degrees it could be out.
For measuring.
But Terry, it's a pretty good one.
Okay.
Theodolite.
Oh, there you go. Now, theodolite. Now, there are apps on phones called the, conveniently enough, the Theodolite app, and now the accuracy of the Theodolite app on like my phone here is 0.1 degrees. So still at 45 feet elevation, it's not precise enough. You really want to get ideally a full order of magnitude better precision. So you'd want something accurate to 0.01 degrees. Right?
Yeah.
So a theodolite, a good theodolite, is accurate to maybe 5
See
arc
that
seconds.
challenge,
That's a
Blue
decent
Marble?
one. A really good one is accurate to 1.
What's that, Renee? Me?
Yeah,
I issued Blue Marble Science a challenge.
Okay.
okay.
Yeah, I know. I'd be doing it with all machinery and jigs and dovetailing things and everything. And Blue and you guys would probably be using all your hand tool stuff. Which I can still do. I can still use the hand tools.
1 arc second. Now, do you know arc seconds, how that works?
Yes. Okay, let's take it to another height. Have you seen the videos of the high altitude air cameras on balloons?
I have, but none of
That's
them
it.
have
Change the
any
subject.
leveling mechanism in them, so you don't know where
Oh, of course. He didn't like
the
where that
eye
subject
level
was
is,
going.
so there's no
Yeah, he sort
measurements
of
in
jumped
them
to that.
to reference. So unless you're going to bring one, and I've never seen one, unless you can reference one that actually has either a very accurate leveling gimbal on it.
Did I miss a mention of what a theodolite's degrees were? What its accuracy was over distance?
Yeah, somebody spoke over him. I think it was like
Because I missed
arc
that.
second.
Yeah, I missed that. How far back was it? Because I wanted to hear that.
Not too far back.
Conveniently enough, the theodolite app, and now the accuracy of the theodolite.
Oh, he's talking about the theodolite app, or did he actually
Yeah,
mention?
and
or
then
did he-
immediately after he goes on about a theodolite itself.
Right. Okay. Yeah, that's what I wanted to hear.
Light app on like my phone here is 0.1 degrees, so still at 45 feet elevation, it's not precise enough.
No, it's not. No.
You really want to get ideally a full order of magnitude better precision. So you'd want something accurate to 0.01 degrees. Right?
Yeah.
So a theodolite, a good theodolite, is accurate to maybe 5 arc seconds. That's a decent one. A really good one is accurate to 1 arc second. Now, do you know arc seconds, how that works?
Yes.
Yeah, there's
Okay, let's take
3,600
it
arc
to
seconds
another
in a
height. Have
degree.
you seen the videos of the high altitude air
What's the? Yeah, he jumps around to that.
Yeah, but there's
you-
3,000. There's 3,600 arc seconds in a degree.
Yeah, because it's 100 minutes, 100 seconds, and then
That is, it's 60 seconds. It's 60 minutes to the degree.
oh, is
and
it still 60?
seconds.
Okay,
It's 60 seconds to the minute.
right.
So what would that equate to 0.1 degree accuracy for the theodolite app on your phone? How many arc seconds was
Way too many.
Yeah.
that? Way too many. Okay, right. That was the part I
Yeah,
was
that's
trying
like
to.
400 arc seconds.
Mm-hmm.
A tenth of a degree is like 400 arc seconds or something like that.
Yeah, it'd be several
Well-
minutes.
It'd be 360. A tenth of a degree would be 360 arc seconds, wouldn't it?
Yeah. It would.
Yeah.
cameras on
Sorry,
balloons?
I
it
have-
took me that long to divide by 10 as well.
But none of them have any leveling mechanism in them, so you don't know where the eye level is. So there's no measurements in them to reference. So unless you're going to bring one, and I've never seen one, unless you can reference one that actually has either a very accurate leveling gimbal on it, and then we can use the center of screen, or a built-in level inside the mechanism. None of them will tell you whether or not you're seeing something rise to eye level. But you can do it in a plane with a phone. Because in a plane, you're looking at 2 to 3, maybe 3.5 degrees is what must happen if the Earth is a sphere, right?
Yes.
We can do the math on that the same way. So right, so we could we can do here, we could say here I have on here we could do Mount Everest, which is lower than an airplane. But we can do for Mount Everest, the dip would be 2.6 degrees apparent, 3 degrees with no refraction included. So that's enough for a phone to do from Everest.
Could you just pause a second,
an airplane is
Terry?
higher than that. So what you could do then is, you know, if you, next time you go on a flight.
I just want to say, Blue wins the carpentry challenge or the furniture making challenge. He's the first one to get a nice photo of a jewelry box in the Discord. Sorry, Renee and me, but you know.
And there are more.
Yeah. Blue was ready for your challenge.
Yeah, I love woodworking. It's glorious. Neat stuff.
Flight. Yeah, do you fly much?
No, I actually don't like to fly. Scares the living shit out of me.
Really? But you have flown.
Yeah.
Maybe
yes,
you
I
could
have flown.
maybe you could ask your son to do that.
Yeah, I
for
might
you.
have him check it out next time he flies, because he flies a couple times a year. But to your eye, though, you're seeing level.
Well, our eye is. Do you think what's the precision of your eye for measuring degrees?
Wolfing.
Pretty good. On my
I'm
eyes, I'd
fine.
say.
I'm fine.
But
Trust
no
me.
matter how high.
You know how many degrees?
Sorry, that old chestnut, your eye level thing, that made me choke on me coffee.
Precision.
Yeah.
Sorry,
and
your
what's
eyes.
what's the accuracy of your eye for discerning a difference in angle vertically?
Terrible.
Yeah. 5 or 6 degrees?
Something like that. I forget off the top of my head. I think MC Tune brings it up here in a second.
Oh, okay.
I doubt it's that good.
That's a tough one to call.
Yeah, I would say the human eye is maybe accurate to 5 degrees at best. But here's what you can do. Like I said, you can get a theodolite app. Now I'm showing it right now, and I know you can't see it, but let's see. That's not showing very well. Here we go. So there you go. There is on the screen now, and I don't know why you can't see it, but I have used my own phone, the very phone that I still have here, flying from Anchorage, Alaska to Minneapolis, over the Yukon Territory, just in rural mountains there, nothing around but mountains, and the theodolite. Now you can calibrate the theodolite. I did it the day before at the mouth of the Kenai River near Anchorage, Alaska. So that's the best way to do it. You go right down to the ocean. So I was toes on the water was lapping up on my toes to do this. And I leveled it here. It's I actually got it. There's 2 things on the screen. You can't see both of them because they're overlapping. There's a line that is 0 degrees, and then there's where I'm pointing, but they're overlapping. And funny, the horizon is below the measured eye level. Now I can send you. I'll do this so you can look at it later at your own leisure.
Yeah, if you want to go ahead and send it on my Facebook or
there you go.
then I can
it's on your
enlarge it
Facebook.
and see it.
And so there, if you scroll down about halfway down the page, you'll see the one I'm talking about that I talk about where I was flying from Anchorage to Minneapolis. But that's not the only one. There is, ooh, that popped away. There it is. There's another one here by Globular Epic Bikini at Flat Slug Brains on Twitter. Another one there. He actually pointed down to the horizon from the airplane and got a 3.3 degree dip of the horizon from the airplane. Another one from D Wolfman 54, where he pointed it straight ahead. The horizon did not rise to eye level. So So those are a couple from airplanes.
Oh, there's that water level
So
one.
you haven't measured it from an airplane, and
Stop
your
up.
measurement of it was not precise enough. So did you do anything else to measure flatness?
We can go with shadows. You can take and say pick a mountain or a skyscraper and put a perfect white backdrop behind you, brilliant white, and watch the setting sun on a nice bright sunset, and you will never have a shadow stand taller than you.
Whoa, I've got that video. I think Wolfie did it. When he's in a building, in a
You mean the
skyscraper.
tallest?
Yeah, he's in a tall building, and the sun's going down to the horizon, and the shadows are above your head.
Yeah, I think that's called the Empire State Building, isn't it?
Oh, I can't
Tallest
remember. Yeah, I can't
Whatever
remember
the
which
tallest
building
building
it
in
was.
New York was. Pretty sure. It was in New York.
I don't know which building it's in. I'll have to play it again. Yeah, here's where Wolfie's video would have helped. Yeah, I've got that video, Carl. It's laying around somewhere.
Than a person.
Than yourself. With a backdrop, watching a setting sun from an elevated position, your shadow will not be taller on that backdrop than you are.
Well, I've got that video.
Yeah.
Like you stand up a board in front of you?
No, behind you.
Vertical, or do you lay it down?
Vertical. No, vertical. I'm not long.
Okay.
I'm talking taller than you.
Why would you expect?
A setting sun would be below you on the ball earth if you're on an elevated position.
Yeah, and how much?
Your shadow should travel upward.
Yeah, but here's the thing. We already determined, like, if you're 45 feet high, the horizon, the dip of the horizon is 0.1 degrees down. So that angle of the shadow, at best, at 45 degrees elevation, would be 0.1 degree angled higher than...
It would be higher.
Yeah, but 0.1. Now, the problem is the edge of the shadow, because the shadow isn't perfectly crisp on there, the edge of the shadow is going to be, the fuzziness is going to be thicker than anything about 1.1 degree. Now, so again, if you went to a high elevation, say you went halfway to Everest, and maybe you could have a 1.5 degree of dip of the horizon, right? You'd have on that shadow 1.5 degree raising as the sun set. But how did you measure that amount of? It's a pretty small amount. So did you actually like calculate how much you expect it would be taller?
No, I just know it would be taller if the ball earth were true.
Okay, so again, this is the same problem where you didn't actually do any measurements. You didn't quantify
measurements.
You didn't actually write, like, what? That if
Measurements? What's measurements, donkey? What's
It's
measurement?
the thing that flat earthers don't do.
Yeah.
Oh, you mean those squiggly lines that have got things with symbols and... Okay.
Yeah,
Not
well, you
words.
know what they say. Measurements aren't part of science, so.
Who said that?
Flat earthers. They
Flat
say
earthers everywhere.
measurements aren't science.
Oh, okay.
If the Earth is a sphere with radius 40,000 kilometers, then at this elevation,
I think you
the
misspoke
shadow
there.
must appear this much higher because the trigonometry demands it. You didn't do that. You just said it should be higher. You don't know how much it should be higher, but it should be higher. It didn't look to you with your imprecise measuring instrument, your eyes, that it was higher. Therefore, it's...
Okay.
Yeah.
Here's another one. Okay.
That didn't work, does it?
We
Okay.
stand on the seashore. I'm 6 feet tall. Say my eyes are 6 feet tall.
All right.
The horizon's at 3 miles. Okay.
Okay.
Beyond that, I start to see a ship disappear below the horizon. Okay. I wait till that ship's completely gone. All right. It's went over the curve, wouldn't you say?
Well, it depends. Did the ship get so small that you could not resolve the detail, or did part of the ship get obstructed by the by the horizon, and then more of it, and then more of it, and then more of it, and then it went away. Which one?
You see it start to disappear.
Okay, so part of it disappeared.
And then eventually you can't see it anymore.
And then all of it gets
the,
obstructed. Yes. Okay.
Okay. Then I can whip out a nice telephoto camera and bring that whole ship back into view.
Oh, so do you have any evidence of this?
You can actually see a lot of the video showing it.
I've never seen one. I've seen people claim it, but every time it's not zoomed out, and what you see is the ship just gets so small that it's unresolvable. It's just too small, right? And then they zoom part way in, and then you can see it then, because now you can resolve it because of the zoom. And part of the hull is obscured. They zoom in more, the same amount of the hull is still obscured. They zoom in all the way, and the same amount of the hull is still obscured. Never have I seen zoom change how much of the hull or the bottom of something is obstructed. I've never seen that. I've seen videos. People have sent me dozens of videos. Look at this one. Look at this one. Never once have I seen that. In fact, here's the challenge.
Spot on.
Watch the sunset. Whip out your telephoto lens. Whip out the best telescope in the world and bring the sun back. Never happens. Nobody's ever done that.
Tell her how it is.
That's because the horizon's so far away where the sun sets.
Yeah, but but you just claimed that the zoom will bring it back after it's gone over the horizon.
The ship.
But it's never happened.
There's plenty of video you can see. I'll work on gathering more of them up.
Well, give us one.
The oil platform ones is pretty cool too.
Oh, not the oil.
We're talking miles.
Here's
miles of video.
Here's a good one.
Why can't I see?
He tells us how it is. It's like, hey, whether you like it, whether you don't, there it is, and whatever.
I got miles and miles of flat ocean, that's pretty close to me. Why can't I go out and look across that and see, Alaska or Japan or Australia or any of these places?
Oh, well, we're on the shadows now. I've got these images put away of these sort of things.
Yeah, I'm going to say, why can't I see the Dutch coast from Yarmouth? I mean, that's only 120 odd miles away.
I reckon I should see New Zealand on a clear day if I had a P1000 or whatever.
I mean, yeah, like the.
Mandelbrot said. Now you live out west there, not too far from Mount Hood, right?
I could Mount Hood is it's in Oregon. I've been there. About 120 miles from it.
Okay. Well, here is I'm sending to you and everybody playing along at home. Second.
If he's 120 miles from Mount Hood, why the hell can't he see it? Mount Hood's the...
Oh, he's going to get into why he thinks he can't see it.
Mount Hood is the tallest mountain in North America outside Alaska, isn't it?
I think it's it might be the tallest mountain in this area, but I don't think it's the tallest mountain in America.
I thought the other ones that were taller than it were in Alaska, but
Mount St. Helens was, but then it kind of blew up. And I forget if it's the next tallest or not. I'll do some Googling while we play a little bit.
Okay, play a bit then.
A PS 9000 from Flatout. Jinx, you said. Have you forgotten? Oh, okay.
Can see. Thank you, Mandelbrot set. Can see the mountain, as you were talking earlier about the shadow being higher. It's. What you want me to give you something?
What's that?
I heard you talking to somebody there.
Oh, my friend Jimmy, I was having to grab me a beer.
Oh, Jimmy. Okay, I got a beverage too.
All right,
there's too
pause
many
it for a
on screen.
second.
Do you guys?
So Mount Whitney is the first one that's the tallest outside of Alaska. The first 10 are all in Alaska. And then Mount Whitney's in California, and we get a couple more in Alaska. The Mount Albert, and I thought Colorado would have a couple because that's the Rockies. So you get Mount Albert and Mount Massive. That one's kind of on the nose. And Mount Harvard. And then Mount Rainier, and that's the one. That was the other one that I was trying to remember.
Yeah,
Mount
Rainier's.
is,
I've heard that one.
And Rainier and Hood are fairly close to each other. And if he's up in Canada, he'd be closer to Rainier.
I thought he was up in. I thought he was in Washington State.
Either way, Rainier would be the closer. Hood's further south. I mean, not by much, but it's still further south.
Okay.
But he should be able to see. I mean, why can't he see Rainier and Hood or whatever? I mean, it's still a valid.
I mean, he ought to be able to see Hood from 120 miles away, oughtn't he? On a flat Earth.
Yeah, yeah.
Oh, on a flat Earth, yeah.
See to me? Oh no, you don't. That's zoom. Wow, didn't expect that. All right, so I have right now on screen Mount Hood. And the sun is right in the process of setting, and the shadow of the mountain is actually being cast up onto the bottom of
The clouds.
Yeah,
Yeah.
amazing. How does that happen if the Earth is flat?
We have a rising horizon that meets the sky at our eye point.
No,
It's
but we
how
already
we-
determined the horizon does not rise.
Why do suns and rise? Why does
We already
the sun
determined that.
rise
I
and
mean, I
set
showed you
in
I
different
showed measurements.
regions according to season? Why does the sun rise and set in different regions of the daytime sky? It's that deflates flat Earth right there. The sun shifts. It shifts from the south. It shifts all around. Do you understand? Do you follow? I mean, the sun rises and sets as seasons progress. It shifts.
Yeah, that's not
Duh.
explained. Yeah, that doesn't explain it on flat Earth.
No, it doesn't explain it flat Earth because they're idiots. It doesn't explain anything on a flat Earth because they're idiots. I mean, come on. The sun. I mean, you can watch it. I've got a highway that runs straight parallel, east to west, and you can watch that sun as seasons progress. It will shift from the southeast to the northeast. It shifts every season. It's like, well, what does that prove? It proves that we live on a freaking damn globe and it's drifting around in space. It's like, yeah, hello. It's not that goddamn. It doesn't take a genius to figure this crap out. Yeah, we are living on a globe that it rotates around. Okay, just drift on.
It's okay.
It's to everybody that there is no, but the rising horizon wouldn't change the angle of the light. That's the problem.
As the sun gets further distance, the sky meets the horizon. Always has, always will. It's how refraction works and our eyes work.
Wow, this is new physics.
No.
It's there.
It is.
It's called horizon perspective.
It is. Oh, this is totally new. But here's the problem I have with that, though. If the sun is how high is the sun again?
I used to think it was around 3,000 miles high, but I don't think it's that high. No one knows.
Oh,
it's
it's
too high.
astronomically high.
Yeah, the old 3,000 mile sun when it sets. If you're on one side of a flat Earth, where does the sun go? Well, it just goes into the ground.
Would you say it's an astronomical unit of height?
In fact, its height changes as it goes from season to season above
One
the Earth.
astronomical unit is the distance to the sun.
And you know that by measuring it?
By the different twilight they have in the southern region, south of the equator, which many people will attest to. They have a very short twilight. Where here in the northern hemisphere, we have a very long twilight.
Okay.
This is
Is he talking about the different times of year or something?
I got no idea.
I think he's kind of getting mixed up between how long, the length of twilight we can get in the summer as we get away from the equator.
Yeah, I have no idea what he was going on about twilight there. Cause
Yeah, our twilight's different to your twilight.
Apparently.
Yeah.
I thought everybody got the same crappy movie and book.
So you did not measure it. Here's the thing. Yeah, we'll get into that in a second. But the angle of the light is still the angle of the light. Whatever perspective tricks you might be thinking is happening isn't going to be changing it. Because if the sun is a couple thousand miles high, then in order for the light to get to the ground, even when it's really far away, it's got to be coming down at an angle, not up, down. So somehow, if the Earth were flat, in order for Mount Hood to cast a shadow on the clouds, it has to come down near the ground and then inexplicably curve an angle back up to hit the side of the mountain and then cast the shadow up on top of, or on the bottom of the clouds. How does that happen?
Through our horizon perspective.
Yeah, how does horizon perspective change
the
angle of the light?
I can keep saying this word.
The sun's setting ain't a few miles away.
Sure.
It's many hundreds to 1,000 or more miles away where the sun's actually setting.
Or millions.
Yeah, but that doesn't explain why the angle of the sunlight
it doesn't explain the angle.
It's because our horizon and our sky meet at our eyesight. It's always has been. That's how it works.
But how does that change the angle of the sunlight?
It's how light works in our atmosphere. Have you ever seen the giant red sun during wildfire season?
Sure.
A giant red sun. Okay. Our atmosphere
does
has many
the-
dimensions to it.
Does the sun only become giant and red
Watch out for
during
our
a certain season?
What you mean when there's lots of extra particulate pollution in the atmosphere?
Hugh, what are you going on about? In the southern hemisphere twilight, we have drop bears rather than werewolves.
Oh, yeah.
You're allowed to come on, Hugh, if you've got the key to the special place over on Discord if you wanted to drop in. I know Phil does too.
See
Yeah,
our
it would be
horizon
nice
at
to
eye
hear from
level.
both
You
of
can
you.
say if the allottonite puts it 1 degree down or 3 degrees down,
Yeah,
wherever
Phil's
you're
got
at.
the special
But
key.
no matter, you take a hot air balloon ride or anything, your eyes are always
Air
going to see that
balloon
horizon
ride
at
or
eye level.
anything. What?
The sky meets the horizon at any height.
Yeah,
It's
but
at
the
eye level,
sun
'cause I said it was eye
is
level.
significantly higher than the horizon, right? No matter what, it's not a couple miles above
it
the
can't
ground,
be.
right?
No, it's more than that because we can't reach it.
Yeah.
But
So-
I don't think it's 3,000 miles away. I think it's much closer.
Well, let's do this. You know
Closer.
what?
Wow.
I measured it. Now you can't see me at all. Is that right?
I see your picture of Mount
Where's
Hood on
my
the
palm
screen.
protection?
Oh, you do see that? Okay.
Yeah.
So
Your screen's only like it's tiny. I can't. I might lose you if I jump around and try to bring you back full screen.
Are you on a phone or a computer?
My computer.
Oh, that's
You
easy
should
for
be
you.
able
Just
to
open
just
another
make
tab.
the window bigger.
Yeah, just open another tab.
On it again.
Don't mention tabs to Tim. He's got all the
I got
tabs
it
open.
bigger.
Okay, so you see that bigger. Excellent.
You'll make him
So
open
here's what I'm
another
gonna-
damn can of it.
I'll stop sharing that because I want you to
And I'm sorry,
see-
but that's horrid stuff, Tab.
Let's see.
They stopped selling it over here, I think.
There we go.
I think
Okay.
they stopped selling
So
it here too.
We're going to.
I
This is our
haven't seen it in
hypothesis
years.
for flat Earth. Okay, not spherical Earth, for flat Earth. Right. There's the flat Earth. That's pretty flat. I used my ruler.
Okay.
Use my ruler.
We can say that's flat.
Right, all right. So now we got our mini Wayne Shipman there on the side, and we got the sun. But I'll do it for Minneapolis. So that's mini tune there. Okay. Now I measured it
Just the
in
mini
September on the day of the solstice. I'm sorry, the equinox.
Where is the
equinox.
model?
When the sun that day goes over what? On the day of the equinox.
Your head.
I'm trying. I would say
Not
it's at
idea.
the equator.
There you go. That's
Probably
right.
above the equator.
Yeah.
Okay.
So now I am in Minneapolis. I am 45 degrees north of the equator.
Okay.
Yeah.
Right. Right in the middle. It's a good
Okay.
convenient spot that makes some of the math easier. So what I did is in September 21st or 22nd, I measured the angle of the sun at local solar noon. That's when it's highest in the sky, right?
Yep.
That's when it was due south of me. So it's straight line from where I live to the equator, and I'm at 45 degrees north. So how many miles between each degree latitude?
I wouldn't know that off the top of my head. I think it's 180, but I might be wrong.
It's 110 kilometers. I don't know how somebody could forget this number. Anybody in the chat
In
know how
terms
many
of
miles there are
idiocy.
between each line of latitude? Lot of-
60 nautical,
6.6.
69
No.
statute, and
Just
111
joking on that
kilometers.
one.
It's a little more interesting than that. Oh yeah, everybody's got
Yeah,
it.
he was
69.
asking
So 69 miles
American miles.
between each line latitude.
That's statute ones, that's
And
69.
I'm 45 degrees
Yeah.
north, so we just
And
go
they're still
45
British,
times
thank you.
69.
Yeah.
You get 3,100.
You guys had them first,
miles.
but you stopped using
Okay.
them. So
We still use them as well.
All right, that-
Oh, you do?
This is working
Oh,
out well.
yes.
I thought you were all
Here we
metric
go.
now.
We've
No,
got
roads and stuff
3,105
is still
miles.
miles.
Oh, okay.
And miles an hour for cars. travelling on them.
Interesting.
Excuse me for snorting.
Miles between myself and the equator
glorious.
on the day of the equinox.
All
Got
right.
that? All right.
Yep.
Now I measured the height of the sun. It was with the small margin of error, about a half degree margin of error, it was 45 degrees above the horizon. So I'll draw that right here. I'll try to get it a little bit to scale. It's not going to be too good because I kind of messed up a little bit there.
McToon needs a whiteboard.
Yeah, he upgraded.
There we go. We've got the sun up here, right there, right? We've got the sun. And the angle, I got to write that down. The angle is 45 degrees. All right, now, I'm sure your trigonometry is better than mine. Right? So here we got this triangle here. 45 degrees, 3,105. And then
I think that would put it about 1,505 miles above the Earth. By that,
no.
I may be off. I've just
You may
taken
be.
half of
You
the
may be off.
90s up and over.
I was giving you the benefit of the doubt at having studied this for so long to have your trigonometry better than I do, but it's a 45 90 45 triangle, which tells you what? between the adjacent and the opposite is the same. They're the same.
Yes.
There you go. 3105. There we go. So the sun, if the hypothesis, if the Earth is flat, then as measured from Minneapolis on the equinox, the sun is 3105 miles in elevation. That wasn't a. You could do the same thing. Pick a day. It's easiest on the equinoxes and on the solstices.
Yes, because we know the exact position.
Yeah, you know better where it is those days. So, so there we go. We know the sun is 3,105 miles high, at least from that one measurement.
Observation.
Now,
yes.
Here's an idea, Wayne. Call up some other friends at different latitudes. You do this with some friends. I'll do it on the same day. A bunch of you, 5 of you, 10 of you, everybody in some flat Earth group. Do the same thing at different latitudes, at local solar noon, and then measure. Just do this simple trigonometry. We teach trigonometry in 7th grade or 8th grade. Like I said, I'm the math teacher and science teacher. So there we are. Then compare your results to see if everybody gets the same sun elevation on the same day. See if that works. That'll be, to coin a phrase, interesting. So so we know the sun now is 3105, at least from this measurement.
From that observation, yeah.
Yeah, so then for Mount Hood, so it's going to vary, I suppose, in your model. It's between 3105 and something else. That's on the equinox. Maybe it's higher or lower at different time. So how is it going to be coming up at an angle then? Because we can calculate how far away from Mount Hood the sun would be at sunset on any day of the year. And it's not going to be more than the entire size of the Earth. Right? It's going to be less than 10,000 miles. Right?
Yes.
Okay, so let's do that. Let's do the math for 10,000 miles and we can find out the angle that the sunlight must be arriving at Mount Hood. There we go. We got. We'll round to 3,000 for the sun elevation, right? I know where Robotham got it. He lived in England, southern England, about 45 degrees north. He measured it on the equinox. That's where he got the number. Same as how I got
Southern
it.
England is about 50 degrees north,
miles.
not 45. I'm sorry, but a 5-degree error is significant there, I think.
Yeah, but you could still do the math for it. I think it would end up with the sun being a little bit higher. But I also don't think that Robotham gave the exact same number that Toon did.
Got our 90 degree here. We got side angle side. You know how to solve side angle side, right?
If I wanted to spend the time getting into the math, I haven't really gone into too much of the math about most of it.
Oh, well, that's a pretty important part of it. So fortunately, I have already pulled up a triangle calculator. I'll share it so you can see it as I do it here. There it is for you. Share it for everybody here.
I just sent a message to Professor Phil Bell. It pretty much sums it up. I mean, if
good.
you
Now
want to take a look at it,
we're doing some real science
It's
here.
real.
We're doing
It's
some
for real.
calculations. All right, so there it is. We've got the triangle calculator. So I need to put in. We got 90 on one side. We got 10,000. And we got this. These are rough numbers, so we can get more accurate numbers if we really want, but they're going to be in the neighborhood, right? So we calculate that. We find out that the angle there is 16.7 degrees. 16.7 degrees. There we go. So It could be more. It could be less. Different days of the year. Maybe it's half that. Maybe it's only 8 degrees on the most extreme. But here's what we have. We have the sun here, right here, 3,000 miles high about. We've got Mount Hood here, and we've got 16.7 degree angle of the sun coming down, assuming flat Earth. So how does that light that's coming down at an angle of 16.7 degrees change its angle and then turn and go up so that it casts a shadow on the bottom of the clouds?
The clouds are near you. The sun is distant, light falls. We have a horizon line at our eye level, no matter how very hard. The horizon rises to meet the sky.
But that,
It's there for anyone to see.
To meet the
rising
sky.
to meet
Ooh.
the sky doesn't make the light change
Fall?
direction.
The light falls. Farther from you, the farther it falls down.
It falls. Unfortunately, So, all right, so hold
Terry?
on a second.
Oh.
Oh, I was muted, sorry. I'll say, the only time I've seen light falling is when I've dropped my torch.
I'll fix my drawing here. That my drawing must be at fault. Okay. Well, I'll start over here. This'll fix it. Right? All right.
He's gonna fix his
Do that
drawing.
again. We've got do that a little crappy there. 3,000. All right, so it falls. Right, so I should curve it going down as it comes, right? Okay.
There are other people who can explain horizon perspective better than I can. But no matter what, where you're at, the horizon, even though it's flat, standing forever, will rise to meet your eyesight.
Yeah, but we're talking about the light angle. So, all right, so here's we've got the Mount Hood here, right? And then we've got the clouds there. But when I made the light fall as you suggested, we got the opposite effect. Now the light is even worse. It's coming in at an even steeper angle. Not round, not curving to go up so that doesn't work. But I do agree. The light does do that because we do know the atmosphere is denser closer to the ground, and when you get up 100 miles, there is almost nothing. It's very, very, very low pressure. So we've got this pressure gradient, if you will, which causes an index of refraction gradient. And the index of refraction gradient causes light to bend towards or away from the higher index of refraction. Which one?
You lost me there.
So I'm wearing glasses. Glasses they refract light. That's how they work, by bending it. So air has a certain index of refraction, and our lens has a certain index of refraction. So when light goes from one index of refraction to another index of refraction, it bends. Which way does it bend? Toward or away from the higher index of refraction?
I'd have to look that one up.
It goes towards the higher index of refraction. So in the atmosphere, closer to the ground, we have the higher index of refraction. Up high, we have a lower index of refraction. That means that the light, as it's traveling through the air, will bend down. Just like in your example, you were right when you said light. Well, you said it will fall. It's a little weird way of putting it. It'll bend downward. That's correct. And so what'll happen is actually if we have a person sitting here on the ground, they're going to look, when they look at the sun, the angle's going to be coming to their eye different, and the sun's going to appear in a different place. I'll show you what that does.
Well, by your curving to the ground there, like you shown, that would prove that the sun does underlits the clouds. Because if the light's hitting there in front of you, it's shining up at the clouds.
Actually, the light is pointing the wrong direction here. It's coming and it's hitting the ground at a steeper angle. And what happens is, it's pretty cool. It makes, for the observer here, it makes that observer think that the sun is higher than it actually is. It actually raises the view of the sun. But it doesn't change the angle of the light in the direction that it needs to for Mount Hood to have a shadow cast underneath it. For that, you need the light to go, and I can fix that. I can fix it. The problem is it's not going to be backed up by any evidence, but that's fine. That's SOP for FE, right? Am I right?
We tend to believe our senses and what we can see, and if you actually open your mind to look into horizon perspective, you'd understand what I'm talking about. The sky and the horizon.
What's this terminology? Open your mind. What? Just completely forget about all maths and logic.
You got to be woke, Terry. You have to be woke. Aren't you woke yet?
Well, Terry, if you open up your mind, your brain can fall out.
You gotta be woke.
And then you'll have plenty of space for all that flat Earth.
Yeah.
Sorry, I'm asleep. I'm not awake.
That's what they say about all the woo, isn't it? You've got to open your mind to it.
Right.
To let all the good stuff fall out again.
Gotta be woke.
Anywhere else further on we could jump to, you reckon, Donkey?
Oh, anywhere.
Anywhere.
I mean, except like way at the end, but yeah.
Like way at the end is where, yeah, that's at the end.
Yeah.
Go on, jump. No, go about halfway. Go about halfway to the end from where you are.
About half there.
Yeah, that should be.
Hope we don't miss any good stuff.
Field is significantly less than
you might want to go back
yes.
just a little bit.
Toon was just now doing pantomime.
He's not presenting. He's not presenting any more stuff either.
Frame that air is moving 810 miles an hour, say.
Okay.
And so all he needs to do, I'm not done talking. All he needs to do is get that slight increase in lateral speed to match that new reference frame. It turns out to
Is he
act
going
on
back
the
to that
plane
again
as
from
a
when they
slight
started?
lateral force. And the plane
constantly
only has to add a slight lateral turn to make up for it. Wind is significantly larger than that small amount of lateral force due to the rotation changing.
Okay. Granted, it's small increments all the way down every 10 miles. It just grows. By the time
Not
it's
every 10
reached
miles. It's
Quito,
constant. It's a constant
at
gradient.
the equator.
Correct.
Oh yeah, he's
It's
kind of on
got
Coriolis
a
and airplanes now, isn't
250
he?
mile
Yeah.
an hour wind. That is its only increase in speed.
But the air moving at the equator is moving at 1,000 miles an hour instead of 800 miles an hour. So that's not wind.
Yeah, this is where they were taking a plane from like
is not
New
on the
York to
ground.
somewhere
It's in a new
on the
reference
same.
frame. It's
Same longitude.
Quito, I think.
Yeah, same longitude, but in the south. So they were
At the
going.
equator. Yeah.
Yeah.
So,
Okay.
like 45 north to 0.
Okay.
No. 45 north to 45 south. I thought is what they were talking
No,
about.
I thought it's 45 north to the equator.
Oh, is that what? Maybe I had
Yeah.
misunderstood it.
Because they were looking at Quito, weren't they? In
Yeah, they
Ecuador,
were.
Is it?
I think so. I don't remember.
It's a continuously gradient reference frame as it's moving south.
But we have a 243 mile an hour push of moving air culminated. Or the increments culminate in 243 mile an hour air moving this plane east, no longer by conservation of momentum from when it left the spinning Earth.
Oh, why does
only-
conservation of momentum stop?
So 243 mile an hour eastward wind. Wind is something a plane can disregard
No,
due to conservation of momentum.
Like I said,
think about
it's
what you say before you answer that.
It's a new reference frame. The new reference frame has wind traveling with the Earth as well at the higher lateral speed.
And it all acts like everything's sitting still, moving together.
No, there's constant wind all over the Earth all the time. Have you never paid attention to like satellite pictures of the cloud formations? Things are moving all the time. The atmosphere is churned constantly.
Do you realize that air has mass?
Of course it does, yes.
And 800 mile an hour air going at each latitude to keep up with the moving ground would swirl around, act still, and they get 80 miles an hour that way, and then 80 miles an hour that way.
Absolutely, yeah.
When it has mass.
Yes, absolutely. Good job. Now you understand why hurricanes travel or rotate one direction north of the equator and the other south of the equator. You just discovered that. Excellent. Good job.
Can you pause it for a second?
Yeah, please.
Can we all just take a second to thank Heat Shield for catching up with what's going on?
Why? What
he thought we were watching a live stream of MC Toon and this guy again.
Yeah, and after that, and also, he's noticed that air has mass and air is moving. And therefore, and the moving mass applying itself to an object is going to provide what?
A force?
Oh, brilliant. Yes, exactly. What's that force going to do to that object with mass? That both and both of those objects have mass.
Oh, we've got a latecomer.
Bubby.
We've got a latecomer turning up.
Yeah, I had no idea you were streaming.
Oh, well, it's in the Discord.
Yeah, well.
Yeah, well, that's okay.
We tried to advertise it as far as we could, Paul.
Yeah.
Oh, Paul didn't hear about
Paul.
my boo-boo that I did with YouTube.
What did you do this time, Cherry?
What did I do this time?
Who
did you offend this time?
Remember when we were doing the trains and stuff? The steam engine stuff?
Oh, yeah.
And we did a zigzag railway video of somebody. And we played a little bit of that. And he sent me a thing on YouTube to say, okay, you've got 2 weeks to sort it out, otherwise you'll get a strike. And me didn't check my emails.
Oh, okay.
Yeah. So I had an opportunity I had an opportunity to correct it, but my fault for not checking the bloody emails.
As in correct it by not putting the clip in?
Well, I could have re-edited it and put it back up without the clip.
Yeah, okay.
Well, my fault.
You'll learn.
No, yeah, one day. 1 year.
Oh, well.
Well,
Sooner or later.
Well, without Alan, I don't know what I'd do.
You'd bug other people to stream on their channels.
Yeah, well, I've been egging Blue to try to get me on his, and I don't know, whoever else has got a channel that I could borrow.
Yeah, I've got access to the Four Swords one.
It's been playing out well. It'll be fine. It'll be fine, Jerry. You know it.
Yeah, I know. I hijacked somebody else's channel one time for the fun of it.
Yeah, there you go.
we just got to get a hold of like Teams or somebody who's big.
Yeah, that'd be cool if I could hijack Team Skeptic's channel. Wouldn't that be funny?
Yeah.
Yeah, hijack Team. That would be cool as hell.
Yeah, everyone would be thinking it'd be Team Skeptic coming on, and the next minute it'd be me, and they go, "What? What's going on here?"
Yeah, what's this all about?
A couple things here. We got holy small. No, I missed a super chat. Somebody said, "Be nice to Chip," and I forgot the rest of it because it's off my screen. I can't bring it up. I've tried, but I'm supposed to be nice to you, Chip. I'm trying.
I think he's being nice to him.
The store are mean to me. No, I love them. They're fun.
Okay, it's Connell Silver Fur says it was the one. So it's Connell Silver Fur. Type it out again. I'm sorry. All right, we've got Holy Smalls as a new member. Thank you for that. JDT Turbo says for $5, if there's a dome and no gravity. Now we haven't gone over this yet, but I think
I love gravity. That's cool. We're gonna get there.
Okay, so if there's a dome and no gravity, what makes the sun, moon, and stars move? It looks like it's a 3-part question here. Also, what makes the seasons, and what's on the other side of the dome? Let's see what we get for that.
What makes them move? Electromagnetic energy, which is what runs our universe. A type of electromagnetic
Well, you've been listening to Lindsay.
We can't really produce.
All right, so wait. This is amazing new physics. How do we know that this new type of electromagnetic energy does things? How was it measured? Who quantified it? And
Lindsay.
how was this? What was the hypothesis for this experiment? I'm excited.
Oh, you missed Lindsay, Paul. Sorry.
That's okay.
Have you seen the?
There's plenty of them. There's plenty more of them.
Superconducting magnets, and they make
sorry,
things
guys.
float by electromagnetic.
Yeah, so like you could get like a 15 Tesla magnetic field and levitate a small plastic ball.
It goes beyond that. They got discs and tracks they can run them on now. It's getting more and more.
But all of those are.
So
have
so
you noticed those that
pause it real quick. So I looked this up the other night when this was playing because, you know, he brought it up. You know, they have the tracks or whatever, which is using super cooled magnets or whatever, and they just came up with a new one that is not super cooled because it only needs to be brought down to -70 Celsius. So. I don't think the world is a super magnet.
And it doesn't behave like gravity at all. It's a thing called quantum locking, and it's not anything to do with gravity.
No, not even close. Yeah.
Yeah.
Yeah, and magnets push and pull. Gravity only pulls. Like there's.
Yeah.
Yeah.
They dip them in either liquid nitrogen or something else. They need to be super chilled. Yeah. So and the magnetic field is very strong. They tend to be larger than 1 Tesla magnetic fields. Yeah.
Well, that's what our Earth runs on.
Okay, and where is this? Where was this multi-Tesla magnetic field? Where is it? Because the Earth's magnetic field is nano-Gauss, not multi-Tesla.
I think actually
there's energy surrounding us.
Oh, hold on a second.
Earth's field's about 0.8 Tesla.
We got this. Been suppressed.
I got this from Connell Silverfur says, you need to be nice to Chip. He admitted early on that Eric Dubé is 1 step ahead of him, so you can't understand him to even understand basic math.
Tell him that was a good one. I like it.
Yeah, I mean, you totally nailed all the trigonometry so far, right?
I don't need trigonometry to prove what I'm talking about.
Okay, all right. Well, so here's the deal. You were talking about electromagnetism. So where is how strong is this electromagnetic field? How many Tesla?
I haven't went into that. There's energy all around us. You generate electricity.
Yeah, but you said electromagnetic, and we do generate a electromagnetic field. It's very, very small. You know, like I said, nano Gauss, maybe, not many Tesla. So how many Tesla is this magnetic field?
It's not total magnetic on drawing on it. we're close to having room temperature superconductors, 0-point energy, and many more things that actually exist and are patented.
Wait,
Okay,
wait. 0-point energy?
Yeah.
Mm.
Well, of course he believes in all that rubbish.
Yeah.
He's just using buzzwords, but he has no understanding of what it
Understanding
actually
of
means.
Yeah, exactly.
Exactly.
Well,
exactly.
I forget if it was this guy somewhere in there or if it was the other guy who, or a guy that Tuna had on another day who was saying that we could have cars that run on water,
Oh,
and
yeah.
you would have a battery
Cars that
that
run on water.
Yeah.
which
Oh,
I mean theoretically kind of works, right? Because you could keep it wouldn't actually be water. You'd want like liquid oxygen or liquid hydrogen, because you wouldn't want to split hydrogen and water. But
No, but that's what they want to do, isn't it? They want to split the water and hydrogen and then use the hydrogen to power.
Right.
Even though you get less energy back from joining, it takes more
Right.
energy to split the
and
oxygen
this
and
is
hydrogen
this was
than
talked
it
about
does
before.
to join it back together again.
yeah. I mean, if you had a battery that could do that in the car, you might as well just run on that
The
battery.
battery. Yeah, the battery would be more,
Yeah,
had more
what
power.
it has been explained before that to be able to do that, you would have to create more energy, money wise.
Yeah.
It's unfeasible. It's unfeasible.
Remember,
Well, it's
'cause
just
that
not
engine-
practical.
It's absolutely unfeasible.
Because the engine's running, they think the alternator gives you free power to recharge the battery.
Yeah.
You know, they don't realise that actually that saps a bit of power out of the engine that is not going to the drive system.
Yeah, and I mean, you know, as long as you have fuel, the alternator will recharge the battery. But like if your battery is being used to create the fuel, then that's not how batteries work in combustion engines. So that totally changes how you're using your.
Yeah.
It's absolutely it's ridiculous. It can't be done. Maybe some idiot could come up with something. No, it can't be done. I'm sorry.
I mean, I'm sure an idiot could come up with an idea for it.
Oh,
Be a good
yeah.
one, but we'll come up with it.
I'm
We
pretty sure.
Cyclical. It's
I'm pretty-
cyclical.
I'm pretty sure Dallas Dave could come up with something.
Oh,
like
yeah, Dallas Dave could. You'd make some shit up.
that. Yeah.
Yeah.
How does that make the sun, moon, and stars move? Where was this experiment done? What was the
I love
hypothesis for this experiment?
Okay, I love this one. For a moment, pretend we have the perfect superconducting magnet.
Okay.
It's called a magnet, okay? The perfect energy field. And Einstein's, I think, things, or Newton's, or whoever the hell,
Somebody.
things set in motion. Things set in motion
Somebody.
stay in motion.
That was
Newton,
pretty good. Newton's first law.
Okay,
Close.
so
And I'm pretty
we
sure
have this
Einstein also
perfect
believed in it.
superconducting magnet and the perfect superconductor, and it was set in motion, and it's eternal. Look at our seasons. Our stars come back to the same position.
Where is this superconducting magnet at?
It's a torus field that surrounds our Earth.
Okay. Where is it generated?
Well, I think it has two generators. We have two rotating star circles, which have been proved by the equator films or of star trails.
Yeah.
Many things you go in on this,
Yeah, that's a
but
problem.
they
Hello.
generate the energy, and
So all right, yeah, but I'm still trying to get
we're
to
going into a lot of theoretical
Well, no, but no,
No
this
one
isn't.
can prove
This
it.
isn't theory. This is you were saying this with certainty. Right.
Yeah, I'm pretty certain it's there.
Yeah. So in
Been there
order,
from the
saying
beginning.
so there's no
with
question that the
with
Earth
saying
has
so with
a magnetic
uncertainty.
field. The north magnetic field is near. It's in the Arctic Circle, and the south magnetic field, or pole.
And how do you feel that's created?
So the south magnetic pole is in the ocean south of Australia. So
Yeah.
Well, it might be.
So you're explaining to us how on flat Earth this is created, but that can't be what you're talking about. That makes the sun, moon, and stars move, because that's very weak in comparison to the type of thing you were talking about for these superconducting super magnets, because they're in the range of multiple Tesla. Do you know when I say Tesla and Gauss? Do you know what those are?
No, I don't.
I don't zero in on any one little thing. I spend a
There it
lot of
is.
time looking
No,
at
I
the
don't.
overview.
I absolutely have no
so
idea.
here's the deal.
I don't.
A Tesla is a measure of a magnetic
Idiots.
field. It's a very large amount of magnetism, actually. Because it's such a large amount of magnetism, people decided, let's not use things in Tesla all the time, because it's all you're going to be dealing with is millitesla and nanoteslas. Let's divide it by 1,000 and call it a Gauss. So 1 Gauss is 1,000. Or sorry, 1,000 Gauss is
Pause it
Tesla.
for a second,
Okay.
because he got corrected. I think it's 10,000
Okay.
Gauss is a Tesla.
Tune
He
was
gets
breaking
correct-
it down. Tune was breaking it down.
Yeah, he got corrected in the chat, and I think it takes him a while to get the correction.
The Earth's magnetic field is much smaller than 1 Gauss, I believe. Pretty sure on that. The magnetic field in these examples you're talking about, where you're levitating plastic or have these superconducting super magnets, whatever, that
They're well beyond levitating plastic.
they're very
Let's say that. They're well beyond that. There's videos of them.
But they're typically 1 or 2 Tesla strong. So the Earth's magnetic field is significantly less than that. So
yes,
how is the sun? I figured you must mean that the sun and moon somehow are locked into an electromagnetic channel somewhere, somehow. Where is this channel? How strong is it? And how is this confirmed?
no one's confirmed
Well, I
it. How
really
do you-
don't have an
okay,
answer for that, but what I'm going to do is just shovel you some bullshit.
It's a wonder he's not referring him to Lindsay's channel.
You
So
want
it's
to
just-
talk about
it's just-
confirmation
It's just a guess.
theory? Or,
right.
oh,
No, all right,
that's
fine.
what everything is. Okay,
Well, you
now
start.
we're
You
on to
start
gravity.
with you can
There
start
it
with a
is.
guess. Hold on. We got a 3-part
I called
question
it.
here. You can
I
start with a
called it.
guess, and then you form a hypothesis to calculate the ramifications of
Which
that
is
guess,
what
and
the
then you
whole Earth
test
has.
it, and then you test
Yeah.
it, and if you
Yeah.
test it and it doesn't work, then you throw out that hypothesis. It's wrong. But if you test it and it does work, then it's confirmed, right? And it's a very strong possibility. So
Okay,
that's how you
how
do
can
things.
you test? How can you test the celestial
And we deal
bodies?
with these people
I don't know.
on YouTube
No one can.
on a weekly basis. Can you imagine that? Why? My question is why?
Because we're all locked indoors and have nothing better to do.
Yeah, I'll buy into that.
You're the one that was
No one
making the
can.
claim. You're the one
Yeah,
making the
so
claim.
does science. So does science. How do you test the celestial bodies?
Well, that's up to you, I guess, to figure out how to do that.
But no one can
As,
figure that
as
out.
a flat Earth scientist, are you consider yourself a flat Earth scientist?
I mean, come on.
Um,
It's
I
fun
guess
to
I can be
point
a
and laugh. Let's admit it.
And just because I have as much study as anyone does in anything
All
on
right,
it,
so
pretty
you're a flat
much.
Earth scientist. I need to correct myself. George Natchik who is much more likely to be correct than me, says that it's 10,000, not 1,000, as the ratio from Gauss to Tesla. I will at this point.
He's got
say you are more
just as
likely
much
correct than I am,
time
but,
researching as anybody.
I
I don't doubt that.
Yep.
Okay. So JDT Turbo's second part of the question: what makes the seasons?
Well,
why do
if you've ever-
seasons happen? What is that all about? Ooh, it's mysticism. It's
ever
some
looked at
kind of
any
magic.
flat Earth simulation, you'll know that the Earth is like a light circling above our circle flat Earth, and it changes throughout the year and creates and goes above the equator and south of the
Did
equator.
you just burp? Come on.
Yes,
Come
sorry.
on, my goodness.
Sorry.
We are much classier than that here.
Hey, sorry. I ain't used to wearing a microphone. I actually looked away from it, but didn't realize it went with my head. I got one of them earphone things with the little thing coming down. Low tack. Sorry. And it moves in and north and south of the equator. And the analemma, I used to know how to
He'll solve the Rubik's Cube while he's explaining it.
solve those, but that was a long time ago.
There we go.
I'd have to learn it
Go,
again.
McCoon.
He starts
They're fine.
twisting away
But
at
the
it.
You'll get it, you'll get it,
analemma-
you'll get it.
I
We
tell
live
him
on
to
a
do it
flat
all the
circle
time.
Earth.
It's like, hey,
All right,
it's
well,
Rubik's
yeah, that's a
Cube
different
time,
topic.
The
So
isn't it?
analemma.
let's stick to the
He'll
seasons.
start
What
twisting
causes the
away
sun?
at it.
You're saying the sun goes in tight circles and then to bigger
Larger
circles.
circle
Too
above
much
and
funny.
south of the equator.
What causes it to change its diameter of its
Hey, dude,
Circle
isn't
circles? Yeah.
above our
Rubik's Cube time? he'll pick it up and start twisting at it. He's hilarious.
Yeah. What's
it's
the
it's
cause?
got it's got its eternal motion set in it. Doesn't change.
Yeah, but that's not the. That's
It
not.
does not change.
That doesn't explain the cause. What makes it happen?
Back to electromagnetism, beyond which we can understand. You could go into quantum energy, all that, whatever you want to call it, and it's got its set path
Whatever you
and
want to call
course.
it.
Yeah, whatever you want to call it. And we'll make up a name
Yeah,
for it,
whatever you
Paul.
want to call it.
That's where his explanation lies. Everything else,
That
everything
was-
else is bullshit. But where his explanation
I
actually
call
lies is the bit where he says whatever you want to call it.
Yeah, that's it. Yeah,
Yeah, I call bullshit on that. You call
Yeah.
it whatever you want.
it's like my videos that
Whatever.
I've been putting out on my channel. Insert title here, like as in just insert whatever name you want.
Yeah.
Don't
That's
know.
been programmed.
Don't know.
So
Neither does science.
You're just the thing
Neither
is
does science.
the science doesn't understand anything about flat
I don't
Earth,
know,
isn't
but
it?
you're
Because
wrong.
It's not testable.
They don't understand
it-
anything
it-
about our celestial bodies.
Oh,
They're all
well,
guesses and ideas.
I beg to differ.
And
on
you
that,
say,
but,
Mike, well,
right.
where's the proof? That
I'm
our
sorry.
sun is a flaming ball of hydrogen 93 million miles away. I
My
mean,
goodness,
where's
God.
any
that's
proof
that's a
of
fun.
that?
Let's review that again. Where's the
The recent
proof
probe we sent,
that the
I
sun
think
is
is
a
pretty good proof.
Let me
I mean, not flaming, but
free frame it there. He's sticking his fingers up.
that's a great face too. So
Never-
somebody screen cap that, please.
Yeah, wait a minute. I might be able to get better. Alright, now go forward. You have to go forward. Yeah, F.
Yeah, right.
Yeah, F. He's going F you. We'll turn that into a meme or whatever you call it.
Yeah. Turn it into a meme and send it to Sideman Dan.
Yeah, F you. It'll be F you.
flaming ball
F-tune.
of hydrogen 93 million miles away? First of all, science doesn't prove things.
No.
There are 4 places that I know of that proof happens.
Tune, he's
and
like,
math.
screw it, I'm on.
In there.
Look at him.
Measuring the purity of alcoholic beverages.
He's on his Rubik's Cube.
Yes.
Baking with yeast. I made bread today. It proved for a
Yep.
while.
Cool.
And then And then the fourth place that people talk about proof is in pseudoscience. Science doesn't prove things. It finds evidence for things, but there's always a possibility that it can be improved. Always. So
Yeah.
where did something get
So it's
proven?
guesses
It wasn't
and
proven. So
ideas.
we measured it. We did things with it. We had a hypothesis. It was confirmed. We did it over and over and over. And over time, these things all added up and they were confirmed. And you get this big bunch of evidence that all fits together and meshes together nicely. That then, in science, people are like, we're extremely confident about that. So when you say proof, I'll just swap in. I'll swap in extremely confident about something. So how did we get extremely confident that the sun is a flaming ball? So it's not flaming. What is it actually? Do you know that it's not actually flaming?
Plasma.
That's not the claim,
isn't it?
It's, I think, nuclear fusion on a large scale.
There you go. All right, so it's not flaming. Okay. So
it's an immense ball of heat. Can we gather that?
And fusion is happening. So how did we gather a whole bunch of evidence that the sun is doing this nuclear fusion? Well, based on the
spectral analysis of our atmosphere looking at the sun. That's one.
That's absolutely. Another is by looking at the nuclear reactions that happen that we've done here, and saying, well, if this is happening in the sun, then we would expect to see different things, different behaviors coming out of it. For example, we expect to see a certain amount of neutrinos coming from the sun.
You haven't figured that out yet.
We measure it, we find that's about correct. We say, well, there should be a certain quantity of photons coming, a certain intensity. We measure that. Oh, look at that. We find that. So a bunch of different things like that people have done to confirm all these different ideas that they had about what the sun must be doing, and say,
Notice the middle finger.
We got a whole bunch of
flatter
matching evidences, a whole bunch of different things. Now, how far away is the sun? I love this one. In the 50s, there were several different times that people that sent radar. They bounced radar off the sun. They had a 40-mile square or long, it's a rectangle, of wire as the antenna to send this signal to the sun. And it's on my website, mctoon.net/sun. If anybody wants to look, I have 2 of them listed there. They sent radar to the sun, and it bounced back, and it took just under 1,000 seconds, about 980 seconds, for the radar signal to go from the surface of the Earth and then be read back again. Now they encoded in a particular way so that when that came back, they got that same signal back. Pretty cool.
Oh my God! So, do you know what you just said?
Yeah.
The radar signal they sent.
Yeah, they sent a signal
to the sun and back.
Yes.
In 987 seconds.
980, about, yeah. What about it?
I was just having a little fun in my mind with that one. Now, when you look at the speed, how we're circling the Earth at 66,000 miles per hour, approximately, almost 67,000 miles an hour, we're moving around the sun.
Yeah, that's
you
true.
with me?
Yep.
Okay, and we're spinning, depending on where they're at. I imagine it might have been the USA. Let's call it 800 miles an hour due east.
Not how rotation works.
That radar signal hit that moving sun, which is moving 500,000 miles an hour, while we're moving 67,000 miles an hour and 800 miles an hour in a spin, and come back to these same receptors.
All right, so
without missing them by
Oh, is that where he was going to go with that? Oh shit! They missed because we moved in relative space. Yeah.
Yeah, but but we don't really need the bearing for the sun, so you just make it very wide angle, and then we can move a degree. Sorry,
Okay.
it's going to take about 15 minutes for the round trip. So yeah, what we're going to move in that.
Fourth, so like 3-4 degrees maybe.
Yeah, so you can, it's not that hard to make the beam 3-4 degrees wide and kind of angle it so so that the reflected, so that if you are trying to go for some forward gain and what have you, so that it's just pointing slightly forward at the time you send the damn signals out.
Well, you're also going. The signal's also going to kind of spread anyways.
Yes,
it's kind of natural.
It will do. I mean, the
especially over those distances.
Yeah, the return signal from the sun will be essentially.
Okay, I'm learning here.
Half a sphere, because it's not really. It's not going to reflect backwards, obviously, but it's going to reflect in pretty much all directions.
Okay.
That the signal's coming from. So yeah. You can move around. You can move around a few degrees, and it ain't going to make no difference whatsoever.
Thank you.
The feet or miles or hundreds of miles.
Yeah, well,
that amount of time.
Of course, your question goes back to some confusions with reference frames, but it doesn't really matter that
they'll
much.
wax motionless because it's taken in the same amount of reference frames.
It doesn't matter that much. Yeah, I do. I love it too. So here's the deal.
I love it.
the signal, it's not like it's not a laser. It's not super narrow. It was a giant, extremely powerful radar signal that went sort of in the direction of the sun. And it bounced back sort of in the direction of the Earth. But everywhere, huge distances to the side of the Earth received that same signal. Not just this tiny little beam. So that's not a challenge at all. The cool thing is that if 980 seconds you divide that in two, you get about, let's call it 1,000, you get about 500 seconds one direction. Are you a fan of One Direction?
We're getting down to 8-minute sun. I know this.
Yeah, so
but we only know the two
500 seconds.
directional speed of light.
Knowing the speed of light.
Don't go there.
You get 93 million miles in 500 seconds. It's amazing. 2 different experiments did the same thing, same amount of time to bounce the signal to and from the sun. It's awesome. Absolutely awesome. Very simple to understand too. No trigonometry in that one, right? There are some different ways that people have measured based on angles of Mars, the moon, Venus, other things like that. That involves trigonometry, which you can't do. So this one's easy. You just need to do about 5th grade algebra solving for one variable. So there we go.
If you ignore all the other movement. Now,
all right. Now hold on. We got one more.
I mean, you don't have to ignore it.
Getting the worth out of this one.
It just doesn't matter.
Also, what's on the other side of the
It's
dome?
just going to make your numbers bigger.
Assuming you think there's a dome.
there is a dome.
Well, no, they'll just cancel out, won't they?
Well, yeah. I mean, not the answer.
what's on the
The
other side
answer
of
will
the
be the
dome?
same, but the numbers that you
waters
work with
above?
up until the answer will be bigger.
Yeah.
Okay.
Science don't know. They can't get past the dome.
Science
What
knows
do you
there's
think
no
we
dome,
never-
but
Do you
question
believe we
for you.
landed on the moon?
in fact, I met Charlie Duke, who landed on the moon.
A question for you, Paul, in the internal chat.
Okay.
Underneath there, I got the book that he wrote and he signed. So I can send you on Facebook. I'll send you a picture of myself with Charlie Duke. So all right.
But you actually believe we landed on the moon in 1969?
Absolutely, yeah. It was amazing.
Okay, now Here's what's funny when someone actually sent me their flight path. It's like a 5-year-old drew it. For all the movement involved. Because back in 69, people didn't know about. You got to give me a little bit here, okay? Let me talk.
I'm just going to give a preview.
Righto, John.
For the audience, it's going to be frame of reference misunderstanding. And all right, go ahead.
Again, I love frame of reference. It's everything's motionless because it's in the same frame of reference. I love that. Okay.
All right.
I'd love to see the trajectory and flight paths mapped out because we have a moon that supposedly is circling us once a month. That's another funny subject. Okay. Add in that speed. Then we have a sun that is dragging us along at 500,000 miles an hour through the universe, and an Earth that is circling the sun at 67,000 miles an hour while it's spinning once a day, which is anywhere from 800 here to 1,000 equator. Send a rocket off, and I think wasn't its top speed around 18,000 miles an hour or something like that, or I don't know.
Yeah, I don't know off the top of my head the top relative to the Earth
Gotta
speed.
go. Later, peeps.
Well, with
Later.
18,
Love ya.
whatever
Later, mate.
the Apollo rocket went, plus 800 miles an hour for a spin. What is their planned flight path to achieve this with 69 technology and everything? I mean, anyone can go online and see all the fakery of the moon landing.
So basically, you're saying you don't understand, therefore fake.
Wow.
That's what it sounds like.
What
to
he's
me.
saying.
Yeah.
Produce the
Like
flight
I remember it. I remember when I was a kid thinking, how could they fake, like thinking from now back to then, and thinking of the technologies they had back then. How would they have faked that? That's.
It could be faked. All of the film could be faked. However, it's a heck of a lot harder. It would be a heck of a lot easier to do it now with digital techniques.
Oh yeah, yeah. You know what ruined it? That movie Capricorn One.
NVIDIA actually made a fake moon landing video. I think like 2 years ago, or maybe it was a year ago, showing off like their newest graphics stuff or whatever. And it actually comes pretty close to being like a high def version of the real moon landing. But we're just now getting that technology.
Yeah, but look how grainy and the type of film that we actually got from the moon back then. It wasn't as if it was high definition quality in the first place.
Well, and a lot of it was live streamed. Like we couldn't have done that live.
No.
Are you kidding?
Well, allegedly live.
I mean, I'm sure there was a bit of a delay on it or whatever in case something went wrong, but it was.
Yeah. I mean,
it was broadcasted out at about the same time that it was happening.
Yeah, I mean, that is the problem. You know, the problem is that yes, it could have been done with the techniques they had available in 1969, but going to the moon would have been easier.
Yeah, and cheaper.
Probably.
Path they planned out to achieve this.
How did they do that? Well, the thing is, because of reference frames, they don't need to worry about the sun traveling through the galaxy, right? You only have to worry about
spinning or the 67,000.
You're right, absolutely. All you need to worry about is the relationship between the speed of the Earth and the speed of the moon. Everything else, because you're in the reference frame, can be ignored. It's fantastic.
I love that.
It's still plenty complicated.
Because everything involved is in orbit around the sun together.
Yeah, because all the other speeds, everything else is doing it at the same. They're all experiencing it exactly the same. So, you know. Oh, and Professor Phil Bell says that there was a 1.3 second delay.
Yeah.
Well, that's the transmission delay. Yeah, but I was saying they might have had a delay, and I don't know, but they might have had a delay on what NASA was broadcasting out to like the people or whatever. And maybe they didn't. Maybe it was just being picked up by the radio waves and stuff like that. But I could see them delay, having a longer delay on what was broadcast out from NASA.
Oh, we're nearly finished.
You can play,
this.
Terry.
Yeah, I was just thinking we're nearly finished.
So, all right.
Frame of reference. I love that. It's like the parent telling the child, well, Santa Claus just magically squeezes down that chimney and comes out and gives you presents.
Actually, no, because remember,
Ugh.
we teach conservation of momentum in elementary school, and
Yeah, I know.
reference frames maybe in high school. So
Yeah.
it's not. Nobody but you seems to have a problem with this. So, I mean, we
have everything's moving, but we take a reference frame.
We've got 250
so
people in the
it's
chat,
not moving.
and they're following along saying, what the hell's wrong with this guy? Why can't he understand reference frames? But, that's you. You do you, man.
Reference frame saying
you.
you got to pretend everything's motionless.
You're within the reference
only
frame. Yeah, absolutely. Yeah. You now understand reference frame.
God.
Congratulations. Okay, we've got
Oh, my God. Okay. This is
Esteban.
funnier shit.
We got Esteban Ilbaca says planes push off the atmosphere. That's at ground speed. There you go. Oh, Man Devil's
Planes push off the atmosphere. Yes, I agree with that.
Man Devil is upset that you're a Santa denier and he wants me to kick you out.
Tell him he better leave me some effing cookies because my beard's turning white.
You know there are 4 parts to a man's life. You know about that?
That you walk on
No,
your hands and knees.
not that one. No. When you believe in Santa, when you don't believe in Santa, when you
Santa.
are Santa, and sounds like you, when you look like Santa. So
I love that.
all right, yeah.
Oh,
So
that one's funny.
Esteban is saying that the planes push off the atmosphere, and the atmosphere is at ground speed or approximately ground speed. So yeah, that's the reference frame. We got Mark Wagner. This sounds good. He says there is no speed compensation.
I think he's just getting into the chats, the super chats type of thing.
He is now.
Yeah, he does super chats for a while, so you can skip ahead a little bit.
I think that's about it for the good derp.
Yeah,
well,
it might be.
I don't know what this is.
No, go back a bit. That's him showing him rainbow without glass. Yeah, somewhere in here.
Just my conjecture. Look into that. See if it can be done without any form of glass being involved anywhere.
So would you? But all right. So what if? That's just hypothetical here. What if I were to show you a rainbow that didn't include that? What would you say then? What is the requirement that only a dome can cause a rainbow? How did you come to that, to be in that position?
I did not claim that's the only.
You said it was proof.
What I said was I'd be interested in seeing if anyone can produce a rainbow without any form of reflective surface involved.
Yeah, but my question to you isn't about that. My question to you is why is a rainbow only possible if there's a dome somehow?
A reflective surface.
Well, why?
I just think that. I'm not saying that's the case.
It's not proof.
This is just a conjecture I'm putting out.
Okay, so why would you do that then? Because
I think
you don't need a reflective surface. You need a refractive surface
to create a rainbow. Is what I feel.
It's just a feeling. Come on, you got to do more than that, right? You want to have some science to it. You want to have hypothesis. You want to be able to test it, right? So here, I'm showing it to you now. Let's see. I'll get it up here so everybody at home can see. Where
I
is it?
see a guy sitting down.
Yeah, there's a kid
like
sitting
he's
down there. All
hooking
right.
something up.
Yep. So here we go. In his garage, this guy's got. You see that pipe there? That's a PVC pipe. So you've got right there the light, right? Just a little basic light,
Yep.
right? And then he'll pan across. We'll see the right there. You can see his the window way over there. You can see it's shining. So the light is shining here, and then this pipe has a bunch of holes in it, and water is spraying out of it. And
Oh, that's pretty cool.
And there's a rainbow. Look at that.
So it can be done.
Absolutely. Isn't that awesome? I love this one. This is pretty cool.
Yeah, that's pretty cool.
All right. So, we got a couple super chats I got to work through. I got my 10,000 subscriber celebration coming up in 7 minutes. So Wayne, we're going to have to wrap it up here actually kind of quick.
Yeah. No, this has been fun, Michael. I love this. That's what people say.
The nautical almanacs have been published every year for centuries.
Oh, yeah.
They document the position of the stars.
Polaris
It's very
keeps
vital
moving.
that they're correct because navigators use them to get their bearings. So in the nautical almanac from 1850, Polaris was not at 90 degrees. It was not at 89.5 degrees. It was at 88.5 degrees. So in 1850, Polaris was an entire 1.5 degrees off of center. In 1900, 50 years later, it had moved to 88 degrees 46 minutes, so about a quarter of a degree closer to the center. By the year 2017, it was 89 degrees 20 minutes. So about just a bit over.
Who's running water?
Sorry, just under 3/4 of a degree. And right about now, it's been a few years, it's getting very close to just a half.
Damn, that's a mighty string.
Over the course of 150 years, about a little more, it's moved 1.5 degrees. Or sorry, 1 degree. So it does move.
Yeah.
It has been moving
but it
for
has
thousands.
A set pattern.
It has been moving for
you
thousands.
Only gave
you said it didn't move. Yeah, we can go back farther.
I said it moved a little bit.
Yeah. All right. Well, that's fine.
Now, if you want to go back thousands of years, who has this proof? It has its cycle. Our seasons work on like a 13-year reset where they go through their whole celestial movement and they come back to the exact same position. And they do this over and over and over. And it can be recorded. You can set a telescope.
But you don't have the problem is you don't have the predictive ability to like look at it and then predict where it's going to be. You just say, "Oh, it was there in the past, therefore it's in there in the past."
That's how NASA predicts everything off the previous movements.
Actually, no.
That's what. Oh yeah,
actually,
they do.
It's been modeled. You can actually look at the source code for Stellaria, an open source software that has all of this modeled out. Or you can use. There's a Python library as well. All open source. Anybody can have a look if they want.
Get me this. We have our ancient stone monoliths with little holes that line up with the sun.
And what's the margin of error of those? How precise is that measurement?
Oh, I'm not worried about precise measurement.
But
I'm talking thousands of years,
many degrees.
and it still comes through. And yes, there's a slight wobble because all of them have their set path.
Yeah, all right. I gotta move on, buddy. I gotta move on. So I got Asylum.
Love you.
So he says,
love you guys. This has been fun.
I got 2 more questions. 2 more things. We got Asylum says, so I take it my offer was rejected. That was to come to Sydney. So yeah.
Yeah.
And then final one. We've got Wacko in Seattle. There you go. He says, is in Washington. I'm in Seattle. Where should I not go?
Okay. Well, that was fun.
Yeah.
Oh yeah, that's right. He was saying that he's in Seattle.
There we go. Oh, well, if we go for a little bit longer, if we could have a surprise section at the end to finish off, because somebody may have something for us that they've already got prepared that I was shocked that they did, and I'm going to give them a pay rise.
Yeah, right.
Yeah, Terry.
He's going to double their pay.
Yeah, I'm going to double what you get now. Yeah.
All right.
So what have you
want
got
me to
for
do
us,
something?
Paul?
You want derp or questions first?
Oh,
Let's do
a bit of both.
All right. Here we go. Let me get the chat up first.
Right, now I must remember to type in the right chat.
Oh no, well,
we're gonna do
it
dirt.
depends if he does the. We can do the dirt first, and we'll finish off with the questions.
Whichever, I must still remember to
Yeah,
type in the right chat.
All right. So, has that come up? Can you see that?
Yes,
Yes.
it's coming up good.
Okay.
All good.
Good. It still works.
Better let Terry put it out to the peanuts as well, though.
Yeah.
It should be.
All right. It takes a little bit to get there.
Yeah, the
That's
delay. Yeah.
All
There
right.
we go.
Yeah. So, weird candy. I'm sure you can all think of some weird candy, but yeah, here we go. What about lollipops with scorpions, worms, and roaches in them?
Seen those.
Yummy.
Actually been to places where you can buy them.
Yeah.
Oh, Gary finally showed up.
Oh, they'd be dead, wouldn't they?
Yeah.
Yeah, I'd say so.
Oh, okay. They're not alive. Okay.
Yeah.
I don't think they get preserved like that.
Yeah. The center of those lollies has got a real bite to it. What about sweets in a urine sample bottle?
Oh.
That's kind of funny.
Yeah. Kind of creepy.
It'd
Yeah, I think that's a
keep
bit
the
bright
kids
yellow
away.
as well, isn't it?
It'd keep the
Yeah. That you.
It'd keep the kids away
Clean
from
up.
you. You'd keep the kids away from your stash in the fridge or whatever, wouldn't it?
Yeah.
Just have a bunch of those in the fridge when friends come over. Start looking like, what the hell? Yeah, that's
It's
definitely a
market-
bad color.
It's marketed at Flat Earthers.
Yeah.
Oh, of course. That makes sense.
Yeah. Yeah, I'd actually try this. Sugared violets.
Sugared violets. Yeah, that's not too bad.
Yeah.
I don't know if I do that one.
It's
Your,
weird,
flower,
but
your flowers are
I
edible.
reckon,
Certain
yeah.
flowers are edible.
Some, not
Oh,
all.
No.
Some
I
flowers.
know they're edible. I just don't know if I'd want to eat them.
Well, I'm sure all that extra sugar helps.
Yeah. Well, yeah.
It does. Yeah. What about gorilla boogers?
Those look like raisins.
Yeah, they probably are.
Also looks like it's either Japanese or Chinese, which doesn't surprise me one bit.
Yeah.
I'm gonna
That's
say
right.
Chinese, but it's because of the stylization on the writing. It's kind of hard to tell.
Yeah. What about ice cream made with cookie dough? Apparently,
Well, yeah.
this restaurant over in the US somewhere does it, and yeah, they did it for a prank once, and people liked it, and so now they do it all the time.
Oh yeah.
So essentially, chilled cookie dough. I mean, you know,
Yeah, that's right.
What's not to like about chilled cookie dough? I mean,
Right,
yeah.
who given the opportunity wouldn't eat cookie dough?
Yeah,
I mean,
they do write on the packet that you're not supposed to eat raw cookie dough, but
Yeah, right.
I do believe when they do it for like this stuff, because you can get like chocolate chip cookie dough ice cream and stuff like that. Anyways, I believe that they make it without the eggs.
yeah,
So because that's normally the problem in the raw cookie dough.
Or what about this one? Toilet bowl candies. As if you have enough trouble trying to keep your kids from doing disgusting things.
Right? Yeah. Depending on the color it is, that could go terribly wrong.
That
Yeah.
couldn't it? Yeah.
Yeah. I think they think their toilet bowl's just cordial, and they'll go and get a straw.
Yeah. Soup candies. Apparently, this is a thing in Japan. One
Yes.
extremely popular Japanese candy is the soup candy. Consumers have to cook this special soup with the given instruments, and then it can be eaten.
Weird. Weird.
Yeah. Very strange.
Yeah, I was looking at the noodle picture of how that'd be a candy.
Yeah. Apparently, there's a lot more flavours of Pepsi than we're led to believe. There's quite a large range of Pepsi flavours. It's just not all of them are very popular, and you don't see all of them on the shelves.
No, you don't.
So, yeah,
I thought they stopped selling Crystal Pepsi.
probably. Why? Because people thought it had meth in it.
No, because nobody liked it.
Okay.
At least here in the U.S.
Yeah.
That Crystal Pepsi almost looks as fun as that time Coca-Cola tried to sell tap water.
Yeah. Camel
Well-
balls and Toro balls.
Yeah, which are bigger?
Pins.
And just so you know, Alan, in the rest of the world, they still do sell water. It's just in the UK that they stopped selling it because you guys didn't like it.
Well, it wasn't we didn't like it. It came out that they were literally bottling tap water and selling it for a huge amount. And that kind of like, well, who's gonna buy a bottle of tap water? I mean, there's nothing special about it.
I
Well,
mean,
there's nothing-
that's all.
nothing
All bottled water is basically tap water.
Yeah,
depending
there's
on-
nothing special about most of the bottled waters.
Oh
Yeah, unless
but-
you're getting distilled water, like
Yeah, well, I mean, you get these things from these natural springs and stuff, but apart from
yeah,
that,
but even those aren't really like spring water isn't really from a spring. Like there's a whole thing. But the whole Coca-Cola thing, Tom Scott did a thing on it.
yeah, I know.
That's the only reason I know about it.
There are actually regulations in the UK that if you claim it's spring water, it's actually got to come out the spring.
Oh, okay.
So
You wouldn't get you wouldn't get much water out of those little springs in the top of your pen, though, would you?
no, Clive Wells, yeah, Peckham spring water. Oh, bugger.
That'd be the phone, Rich.
Yeah, that'd be the phone, Rich.
What about unicorn poop?
Oh, that'd be rare.
They look like just little meringues.
Yeah, I was trying to figure out what if it was like a sucker thing or if it was a frosting type thing. It's kind of hard to tell.
Kit Kats. Apparently, Kit Kats are another thing that come in a multitude of flavors, but you don't see many of them.
Yeah, they're all like Japanese. If anybody's got an Asian market near them, go and try the different Kit Kats. Some of them are amazing. I love like the strawberry ones and some of the other ones.
Yeah, but I mean, having more than 200 different flavors, I mean that's we rarely see more than a couple here in Australia. But the notion that you have to actually bake this Kit Kat before you eat it. Yeah.
I haven't seen that one, but yeah, though, like I said, if you've got, at least here in the US, if you've got an Asian market near you, they will sell at least some of those flavors.
Yeah.
Definitely go and try them. They're quite awesome.
Pickle or bacon flavored gumballs, hey?
I know people who'd probably like those, the
Yeah.
pickled ones.
Yeah. What about edible diamonds?
Oh, there you go.
Yeah.
Diamond that's actually worth something.
Hmm. Yep.
You could fool your girlfriend with one of them.
Yeah,
Yeah,
it's
right.
2 months'
Yeah.
salary, I promise.
Yeah.
Till she has it cleaned and it dissolves.
Yeah, that's it.
Yeah. Yeah. Oreo cookies are another thing that come in a multitude of flavors too.
Yeah.
Well,
Not all of them.
Yeah. Chocolate with bacon, mushrooms, and smoked salt.
Oh, yummy.
Interesting. Okay.
How can you have
Yeah,
smoked
different.
salt? It's salt and
Well,
smoked.
Yeah. You smoke the
not?
salt.
Okay.
Yeah. Vegetable flavored ice cream.
Oh. I don't know.
Tomato flavored, carrot flavored, beetroot flavored ice cream.
Oh.
I mean,
Carrot and beet, maybe, but I don't know about the tomato.
tomato is a berry.
Yeah.
Or no, it's not a berry, but it is a fruit.
Now
What
that's a king python.
96 inches.
That's awesome.
Yeah, that would take you a while. That'd send your kids psycho.
I was gonna say you just get a couple friends.
Yeah.
You would share your worm.
Yeah. Apparently, this is a thing in Texas. The barbecue payday bar.
Interesting.
Yeah.
I don't know.
I've never heard of them, but yeah.
Payday. So it's basically just peanuts and caramel normally. Like
Yeah,
that's
it's
all it
just-
is. It's just a peanuts stuck into a bar form using caramel.
Yeah, it's basically what we call a Snickers here in Australia.
No, Snickers are different because we have Snickers too. Unless you have a different Snickers.
Yeah.
But normally the paydays don't come with barbecue. Like that's the interest.
Okay. Yeah. Apparently, this is a thing in Germany.
Nice.
Yeah.
Or
An ass with ears. It literally is an arsehole with ears. Yeah.
It might be a dumbass, but there's no reason to be a deaf ass.
Yeah, that's all right. I like the comment there, someone at some point looked at the candy market and said, this is what's lacking in the current industry. Yeah. Oh dear. Squid candy. Japanese squid candy.
I mean, of course it's Japanese.
Yeah, that's right. Thanksgiving gumballs. Who's juggling coins in the background?
I'm not doing anything at the
sorry.
moment. I'm not in the kitchen
Yeah.
making coffee this time.
That was me.
Thanksgiving gumballs also claim to contain a 3-course meal in every tin.
Didn't Willy Wonka try
gumballs.
and do that and fail?
Yeah.
Oh no,
The
I think he had a
flavors.
5-course.
Flavored as turkey with cranberry sauce and pumpkin pie, respectively. Yeah. So here you go. In the 1960s, the classic American dispenser candy Pez released a flavor based on chlorophyll. Yep, the chemical compound that makes plants green. With that, as well as another 1960s Pez flavor based on flowers, it seems Pez was really taking the 1960s counterculture concept of flower child to a whole new level. Yeah. Chlorophyll flavored Pez. Wow.
Okay.
Crime scene crime scene candy tubes.
Mhm.
Yeah. Yeah. No thanks.
What?
Yep. When gravy on your meat, potatoes, and peas is just not enough.
No,
You have to have
gravy candy. Ugh.
gravy candy as well. Yep.
I will say,
Yeah.
like for those crime scene ones, normally those aren't too bad because it's just like a normal like candy or whatever. It's just
Yeah,
the
yeah.
container that's goofy.
Yeah,
But like
yeah.
this, where it's like gravy candy, I don't know. That's
Yeah, yeah. Remember when you were a teenager and you had zits and you used to pop your zits? Well,
Oh.
now there is a candy where you can do that. You can do
oh
just
god.
that.
Oh no.
Oh no, that's just wrong.
Uh, and you gotta love the next one.
Oh,
Of course.
read the caption out.
Yeah. Spermies, the candy you love to swallow.
Words failed this moment in time.
Yeah, they do. Yeah. Popular around Chernobyl, X-ray fish.
Oh, okay.
It looks like it's fairly large too.
Yeah.
You could have a whole range of candies from Chernobyl. Yeah.
Yeah. Yeah. This looks interesting. Draft
Okay.
chili bean. Yeah.
Okay.
I wonder how many it takes for it to get a standard drink.
Yeah.
The whole can.
Right, yeah. Breakfast lollipops. Now, the question I have, of course, is who the hell eats donuts for breakfast?
Wait, who doesn't eat donuts for breakfast?
No.
That's-
No.
Yeah, your stomach
That's
doesn't
just-
know what time of
that's
day
just-
it is, you know.
Yeah.
All Americans eat donuts for breakfast.
Oh, okay. And the final one. Now Nathan Oakley can have big nuts in his mouth whenever he wants.
Okay.
So my question to you is when do you eat donuts?
Oh, donuts are for dessert.
I'll eat donuts any time of the day. I don't care.
Ah.
Well, I mean, I'll eat them any time of the day. I was just like, if they're not for breakfast, I was curious. Like,
I mean,
Or when you go to the market and you get the donuts from the little side alley
I
from the
feel like
donut truck.
I feel like a
Yeah.
donut now.
Or you go to the
Yeah.
show.
Yeah.
You go to the show and you get the donuts. Or the Dagwood dog.
Oh, the Dagwood dog, yeah.
Yeah, yeah. And the fairy floss.
Yeah, okay, yeah.
Yeah. Anyway, that's all I had for you for Media Day.
Oh, that was
You
cool.
enjoyed
That was funny.
All right.
Now I'm going to be
So,
looking in
but
the
I-
cheap shops and everywhere for all these different variations of lollies.
Yeah, right. All right. So you want some questions?
back again.
I
What?
mean, I assume.
So what did Reg want?
Are you talking to me, Terry?
That's okay. You don't get the reference. It's probably an Australian thing.
Yeah, I think it's an Australian thing. No, that was Nathan, because my grandson wanted to show me his new favourite toy, a 13mm combination spanner to go with his 10mm one.
He's going to have more tools than you.
Yeah, and the best bit was he nearly choked his dad with it because he decided the best thing to use the spanner for was tightening up Nathan's tonsils. But there you go.
Sorry, Ali. It's Little Wolf is questioning your back alley donuts.
What? Back alley donuts.
Back alley donuts.
Actually,
No. It wasn't back alley. It was side alley.
I'll have you know the fresh donut thing is right in the main concourse of Yarmouth Market.
Oh, okay.
When I was younger in Wollongong, they used to have a fresh, just normal donuts with the cinnamon and sugar, and they'd cook them while you waited. They weren't pre-cooked. You ordered, say, 6 donuts. You watch them go through the machine and back out, cooked in a bag, hot. There you go.
Oh man, that would be amazing.
Yeah, it was.
Did they have? Could you get them with jam in the centre as well?
No, they were just plain cinnamon donuts. That's all they were back then.
Yeah.
Only a small
I
little
always
shop.
used to be wary of getting the jam ones because the jam ones are okay. They feel okay on the outside, but then you bite into them and this like molten jam comes out, and it's like freaking 2,000 degrees.
Yeah.
But you're supposed to fill them after you cook them. Somebody made a mistake there. It's not supposed to be like a hot pocket.
Yeah, well, that's what some of them do. And yeah. I think what they do. I think what happens is they have them pre-made, and they just whack them. They whack them in the back room. They whack them in the microwave to heat up, and of course the jam heats up really quickly.
It would do,
Yeah.
The office is putting out the answers to the questions already for you.
Ah, okay. Well, we better have some questions then, hey?
Yeah, well,
all right.
The first one better not be
go.
right, they'll mix, because there'll be something fishy going on if it is.
Yeah.
Now, just make sure I mustn't type in the live chat.
Live chat.
Yeah.
Yes,
I will not
yes, Peanuts. Do not say tag Alan, so he accidentally types in the peanut gallery. Just please do not tag him. Like if you tag his name, he'll type in there accidentally. Hint, hint.
John Rapp. Yeah, question will be multi-choice A, B, C, and 4. Yeah. All right, question 1. One of the following is a device that detects charged particles but does not show their tracks. Is this device the spark chamber, the photographic plate, the scintillation counter, or the bubble chamber? Which one of those detects a charged particle but doesn't show its path?
I have no idea.
I'm going to have to go with that one.
I like Irish stew.
So you get some clues. You've forgotten about that, Terry.
No, I put X in. I put X, so that doesn't count.
Okay. So that is what a spark chamber looks like. That is what a photographic plate looks like. That is what a scintillation counter looks like. And that is what a bubble chamber looks like. Which one?
I think it might have been that one.
Oh my goodness, Terry. Have you got your microphone next to your fan or something?
No. Not me.
The aether bubble chamber.
Yeah. The correct question, the correct answer, it's obviously the correct question, but the the correct answer, maybe I'll do that one day, do a reverse one where I have the answer.
Jeopardy
question, yeah. The correct answer is C. It's the scintillation counter, because all of the others, the spark chamber being that one there, you can see the path that the charged particle takes. The photographic plate obviously makes a record of the path that the charged particle takes, and so does the bubble chamber. The only one is the scintillation counter. It counts events, but it doesn't show them.
That's what the clue get. That's what the clue in the answers was before you gave the picture clues.
Yep. Good.
That's why I got the X, because I pressed X instead of C on the keyboard.
Yeah. All right. Question 2. This world-famous volcano erupted in 79 AD, 1139, 1631, 1779, 1793, 1872, 1906, and 1944. Name this volcano.
I know it. Just forget its name.
And it's not the one I'm thinking of either. So that's a different one.
I mean, it might be.
I think it might have buried a biggish city in 79 AD.
Yeah, that's what I was thinking. It was.
Yeah, it might have too.
Yeah.
I can't spell it. I can't spell it properly. Oh, Alan did the same word. Yeah.
Okay. I get what you mean, Terry.
Yeah.
That's the one I was thinking too.
Yeah, that's the one I was thinking.
And when it does erupt again, and if it has a Plinian eruption, Naples is going to be
gone.
Yeah, forked. Yeah,
because you're looking at that,
volcanoes aren't real, so it doesn't matter.
If you look at that volcano where the top's missing, like you think of Mount St. Helens, and you think, wow, that's a lot.
Yeah.
Well, that is
exactly.
It's likely to do a Mount St. Helens, isn't it? That's the
problem. Is sometimes. Yeah, it does both kinds of eruptions, and you don't know which one's going to happen.
Because it was the Mount St. Helens type eruption that did for Pompeii.
Yeah,
and that's what I was thinking of Pompeii. That was my first thought.
Yeah, so the correct answer was Vesuvius. Okay, question 3. If the diameter of a reflector's objective mirror is doubled, how many times as great is its light gathering power?
Nice answer, Mute Donkey. That is kind of a good way of getting around that number.
Yeah. There's your clue, which kind of gives the answer anyway. And most people, not everyone, get it. Some have gone the wrong way. It's 4 times the collecting power. Yeah.
Yeah, that was my only delay. I was like, let me make sure that I am go in the right direction with this one.
Yep, that's right. Yep. Okay, question 4. Of the following elements, which has the largest atomic radius? Is it barium, fluorine, carbon, or beryllium?
I don't remember. Actually, I don't know.
And no, Sir Little Wolf, a quarter doesn't count because it's a coin. Coins can't count.
Wait, what?
He said, does a quarter count? Of course not. A quarter's it's a piece of metal. It doesn't count.
It's also going in the opposite direction.
Yeah. When have you ever heard a quarter go 1, 2, 3, 4, 5?
Okay. Here.
All right. Some people might be needing a hint for this one. So here's a periodic table of the elements.
That's what I was waiting for.
Which tells you where those elements are, if you can find them quickly enough. Most people seem to have some idea of, oh no. Oh, most people seem to have no idea.
Oh, okay.
Yeah. Let's see what Clive has got.
No, that's not what I meant.
Clive would have it right, of course.
Yeah.
Because you see that beryllium, carbon and fluorine are all towards the start of the periodic table. They don't have many electrons. And so you'd imagine that its atomic radius would be less than barium, which is a lot further down the periodic table. It's got many, many more electrons, and so it would have a larger atomic radius.
Can you explain the radius easily or not?
What's that?
The terminology of the atomic radius.
Oh.
Basically, as you go down and right, the atom gets heavier and therefore it has to get bigger.
Right. Okay.
That's the one that I was having trouble finding, was barium.
Yeah. Okay, question 5. The maintenance of a relatively constant internal environment, despite external fluctuations, is known as what process? So in other words, an example of this might be maintaining your body temperature despite the external temperature fluctuating.
Oh. Are you talking about
maintaining the concentration, the acidity of your blood, despite all the various different acidic or basic foods that we put into our bodies? Or the maintenance of a certain level of glucose in our blood, despite us eating and not eating.
I think the chat has it.
Yeah, I was just wondering. I think
They do.
I recognise that word now.
Yeah, except they're kind of, they're kind of missing one letter out of it. It's not homostatus.
Yeah.
Right? Homostatus is the status of a homo. Right? Yeah. It's homeostatus.
We're all homos here.
They're all homos, chat.
Yeah, I'd still give it to them though. They're clever enough.
Yeah, that's right. Yeah, it's homeostasis.
Yeah,
that's what it is. Yep, correct. Okay, question 6. Which of the following was the founder of Bluetooth?
Bluetooth. Okay.
Yeah. Was it Ericsson, IBM, Apple, or Dell?
I was thinking of Wi-Fi, but Bluetooth's different, isn't it?
Might be off on that one.
Yeah.
Long John Silver.
Yeah, because
I was thinking it was one company, but that company's not on that list, so
Yeah.
it's obviously not that.
I know I don't like my answer, but I'll just have to guess.
Yeah,
that one.
Hugh Jas has got it. It's remember King Harold Bluetooth of Norway?
Yeah.
so
Yeah.
That
We have talked about this
one.
before.
Okay.
Yeah.
I mean, the symbol is
It's the Nordic H and the Nordic B put together,
Yep.
right? For Harold Bluetooth. Okay. And being Nordic, of course, Ericsson would be the company. So
Yeah.
it's Ericsson. Yeah.
Yeah, I knew it was Ericsson or Dell. I just couldn't remember
Yeah.
which. And then afterwards, I was like, it's probably A.
Yeah. Question 7. The photomultiplier tube in the scintillation counter multiplies one of the following. Does it multiply scintillations, electrons, ions, or photons?
For the lulz.
Just seeing how people's memory is from the questions before.
Yeah.
Who's been paying attention?
It's just really early in the morning.
Oh, okay.
Yeah. I mean, we did have a diagram of a photomultiplier tube earlier that showed you exactly what it does. So let's see who was paying attention. Hey?
Yeah, that's it. MakeGift.com even had one.
Yeah. And there's a gif of how a photomultiplier tube works.
Yeah.
In the end of the photomultiplier tube is the scintillator, which is the bit that gives off the light. The light then impinges on a coated plate that emits an electron. That electron is drawn towards a positively charged plate, where it hits and gives off more electrons, which then travel towards the next negatively charged plate, which give off even more electrons. And as it bounces from plate to plate, they give off more and more electrons until they hit the final electrode at the end, and it then registers as a pulse in your detector. So it multiplies electrons, folks. Yeah.
I knew I was wrong, I just didn't correct it.
Okay.
It's slightly misnamed, isn't it?
It is, yes. Yep. 8. Name the mountain. Here's an easy one for you. Name the mountain range located in South America, which runs through Peru.
Oh, I have to know your geography. Is it? I don't know. Is this a mountain range?
It is, but you're on the wrong continent.
Oh, am I? Okay.
Yeah, you are on the wrong continent. Most people seem to know this one.
Yeah. You find them at the end of your arms is...
Yeah.
Oh, okay.
Yeah,
I don't think that's much of a clue.
Mr. Warhol was one of these too. It is the Andes.
Well, which country's the one I give the answer to?
America.
Oh, okay.
It's the Appalachians is the mountain range on the East Coast.
Oh, okay. Got wrong continent.
Okay, question 9. Of the following phases of the moon, which is the one at which a spring tide occurs? Is it new moon, new gibbous, first quarter, or new crescent?
What's a spring tide?
I I guess you have to know that to answer the
Yeah,
question,
the
don't you?
Yeah.
I can tell you what a spring tide is, but it would involve describing where the moon is.
Well, I know you could.
Donkey,
just
can you
give the
quickly
really basic
Google
answer that
spring tide for me, quick?
It's when the
I could, but I'm trying not to cheat.
it's when the tides are highest.
Oh, okay.
It's when the differential between high and low tide is the biggest. Is a spring tide. They actually happen twice a month.
Wait. I hit the wrong one.
Well, twice a lunar month, and twice a lunar cycle.
I'll go for that one.
I read the word wrong and hit the wrong button.
Yes, for those of you that know, you'll know there are 2 times that you get a spring tide. One, when the moon is full, and the other time is when the moon is new. A new moon is the correct answer.
Yeah, you threw me off by having new gibbous and new crescent.
Yeah.
What?
Yeah.
Yeah, they're not. Yeah, it should be.
Those aren't things.
No, it should be new gibbous, first quarter, and crescent. Really.
It should. You can have a waning or a waxing.
Yeah, well, that's what
or crescent.
That's what the other terminology is. So new refers to the waxing.
Well, it would be a waxing crescent, but it would be probably a waning gibbous, right? Because I'm guessing it's the gibbous or the crescent that is closer to the new moon.
Yeah.
Like that's what confused me with those terms, because I saw new up there and I was like, oh, pick the one that's there, and then I was like, wait, there's 3. What is that? I've never heard them called that.
Yeah. Okay, question 10. In commercial vulcanization, cross-linking is introduced by the addition of what? Sulfur, toluene, silicon, or phosphorus?
Humans.
Vulcanization. That doesn't mean you become more Spock-like.
Well, I can think of a few that would help.
I was thinking of vulcanization, like as in when you're doing tyre repairs on a tube or a tyre.
The Enterprise?
I've been vulcanized. Now I have no emotions.
I'm only half vulcanized.
Everyone's answering Spock.
Yeah.
Live long and prosper.
Yeah.
Right, that's what I did remember. It's something, but I couldn't think of the answer because I was thinking of the rubber to do with the tyres and stuff.
Yeah, come on. This is a standard science thing in high school for everyone. Everyone learns about vulcanization of rubber in high school science, surely.
You mean that everyone should have?
Should have, yeah. Because the correct answer is you add sulfur. The cross-linking happens with sulfur atoms.
I didn't take chemistry.
No, this is something that was done way before chemistry came into the picture. It was just done in basic science.
Oh, not in any of the schools that I went to.
Okay. Question 11. Animals whose activity peaks at night are called nocturnal. We all know that. But what term is used to describe animals that are active during the day?
Horny.
Oh, wasn't that quick, wasn't he?
No.
Wow.
awake.
Awake.
Or possibly even woke.
You found the nighttime,
It's my
daytime.
nighttime bird.
Yeah. Yeah. It doesn't give any clues, but it's a good clip.
Oh man, I've heard this term before, and I just can't remember.
Yeah,
Caffeinated.
we do have some correct answers out in the chat.
Okay, so it
and
is
also
that one
in both chats. Yeah. Yes, Alan Evans, Clive Wells, and Sir Little Wolf and Milkman Dan.
And Carl Edwards was really on it
Yeah,
quick.
he was. Yes, it is diurnal. Yeah. All right, question 12. Which of the following IP addresses, this is for all you computer freaks out there, which of the following IP addresses cannot be assigned to a computer system in a network? Is it 192.168.1.1? Or is it 127.0.0.1? Or 192.1.1.27? Or is it none of the above?
I
mean, there's one that's usually assigned as the default address, but
Yeah, I was going to say there's two on there that can't be used. The other one is actually a little bit more questionable. But I know what he's going for, so I know what the Carl Edwards, yeah. 127.0.1 is your local, but you can still be on a network.
So there you go. The correct
John Rapp,
answer was,
I care because I do this.
Yeah. The correct answer was 127.0.0.1 because it's looped back.
Yeah, but you can't assign 192.168.1.1 because that'll be your gateway.
Did I get one right? Oh, another one right, I mean.
So the 192.1.1.27 depends on the system, how you'd have it set up if you could access that. Most people won't be able to set that up or whatever because they'll be using a system that automatically puts them in the range of 192.168, and then they'll just be able to assign the last two. So that's why I went with none of the above.
Yeah.
Yes, Dan B.
It's just that if you assign 127.0.0.1 to your computer, no one else is going to be able to find you, obviously, because the loopback address.
Like I said, you also can't assign A because it's a gateway.
Yeah. All right. Question 13.
Yeah, binary. That's why I was saying the C was the only one that you could assign without problems.
Yep. Question 13. The emission of a positron from a radioactive atom is generally accompanied by the emission of one of the following. Is it accompanied by the emission of a meson, a baryon, an antineutrino, or a neutrino? So you have this little nucleus and it emits a positron. What else comes out with it?
Wrong type of gateway.
Know?
Professor Bell fall asleep. He's missed out on the questions. I wish I'd have went to a better school when I grew up.
Okay, the correct answer, if you're following the diagram, if you know what any of those symbols mean.
No, that's just
That's the real
I've got
question.
no idea. I've got no
Yeah.
idea. I've got no idea here.
Beta plus means beta plus decay, which means you're giving out a positron, which is the E plus. All right. And the little other particle, which goes off to the left there, is the neutrino.
Yeah, we're following
If
your
you emit
mouse.
an elect,
We're following your
if
mouse.
if you emit an electron, you get an antineutrino being chucked out. But because we're emitting a positron, which is the opposite of a electron, we get a neutrino being emitted along with it. Yeah.
Okay.
Question 14. In which of the following mountain ranges are volcanic rocks least common? Is it the Andes, the Cascades, the Himalayas, or the Sierra Nevadas?
I think I might. I can't remember. If I'm correct in explaining my answer, I don't know if I'm correct or not. Because I'm thinking to do with tectonic plate movement stuff. What do they call it?
Yeah, I think you're on the right path, Terry. I might be off.
Yeah. Yeah, I'm not giving the answer away.
Yeah,
I'm just
Carl,
saying the process. How they're formed.
Yeah, it is to do with how they're formed.
Mm-hmm.
So how is the mountain range that's the answer formed, Terry?
By tectonic plate shifting, or it's similar to that. Where things that get pushed, plates get pushed.
But volcanoes are formed by tectonic plate shifting too. Okay.
Okay.
It's just that different things happen. I mean, like for instance, tectonic plate shifting is what's causing the volcanoes in Hawaii as well.
Right.
So what happens there? The tectonic plates are moving apart. Okay. Some tectonic plates slide past each other. Some tectonic plates collide, moving towards each other, where one subducts and goes under the other one, causing a pressure build-up and volcanoes. But there are some where they collide and both plates push upwards, like as in the
Himalayas.
In the Himalayas, yeah, that's right. Where you have India basically colliding with Europe.
Asia,
sorry, yeah. Yeah.
But there's a big layer of volcanic rock across a lot of India, and I thought part of that was being uplifted into the Andes as well, which was.
Wait, what?
You mean the Himalayas?
Yeah, sorry.
Okay.
Yeah, no, I was getting confused because there's a. I know in India, and I thought it was in the northern part of India. There's a whole area that got covered in a big lava sheet.
Yeah, but typically speaking, the mountain ranges don't contain a lot of volcanic rocks.
He did say less likely.
Yeah, that's right.
Okay.
Yeah. Okay, question 15. One source of acid rain is what? Is it sulfur in fossil fuels? Is it carbon in coal? Is it hydrogen in hydrocarbons? Or is it chlorofluorocarbons in aerosols?
I thought they fixed one of those problems.
I mean, just because they fixed it doesn't mean that it's not a source of it.
Okay.
You're trying to misdirect him, mate.
I'm just saying. Just because they fixed it doesn't mean that it can't be a source of the problem.
Yeah, but it could. Yeah, but it used to be a problem. But is it still?
Well, just yeah, but just because it's not a problem anymore would not mean that it wouldn't be. It wouldn't cause the same thing anymore.
You're not helping me with my answer.
I'm not trying to help you with your answer.
I know, that's what I'm saying.
But if I'm guessing at the answer you're talking about, I thought that was a different problem.
Okay.
It probably is.
Yeah, it is.
It's so cryptic what we're talking about. Some people probably
Yeah.
wouldn't have a clue what we're talking about.
Yeah, I suspect Terry's talking about answer D.
Paul!
Causes a different, which causes a different problem to the question, what the question's asking.
I know.
Yeah. And same with answer C. It causes a different problem than
I'll just go with that one then if I'm not
the
sure.
question's
Then.
asking.
Yeah. When in doubt, I'll go for that one.
That's a good choice.
Yeah. And that was before the clue came up.
Yeah.
I mean, after all the other clues that we gave.
Yeah.
Hey, I wasn't asking for the
Which ones
answer.
it wasn't.
Yes, I know. That's right.
Well, we didn't give you the answer. We told you which ones it wasn't.
Yeah, I know. That still helps. That still helps.
Yeah.
Yeah.
Hey, I know what I was doing.
So the correct answer is sulfur in fossil fuels. Yeah.
I'll keep doing this for all the questions.
I think sulfur is the largest contributor, isn't it?
To acid rain, by far. Yeah.
No, I got no idea for this one.
Come on, this one's easy. The Swan is the English name for this constellation. Even the Latin name by which this constellation is known.
I was going to say...
Is easy.
I don't know any constellations, even Latin.
But do you know what swans are called?
Yeah, I was going to say, you know what swans called, don't you?
Yeah.
The problem is, I don't know the English names to any of the constellations. I know them by their Greek and Latin names.
Well then, you must know the Latin name for a swan.
Not off the top of my head.
Yeah, it's not helping us, is it, Donkey?
Yeah, I mean, as Carl Edward points out, what are baby swans called?
Yeah.
Ugly ducks.
Okay. What Alan said then. Okay.
Yeah.
I figured Alan had it right. I just didn't want to type it just
Yeah.
because he had it in
Yeah,
there.
I know.
Yeah.
Yeah.
You're correct. It's called cygnus. Yeah. Okay.
No, because I didn't remember the name, but I saw you put it. And I was like, Alan's probably right. But I don't want to just steal his answer.
Yeah. Baby swans are called delicious. What, baby swans can't be called dinner either?
I'm sticking with ugly ducks.
Careful, because it's a really serious crime eating swans in the UK.
Yeah.
Oh,
I
is
remember
it?
They all
something
belong to the
talking about
Queen.
that. Yeah. I remember
Oh,
talking about
okay.
that.
Oh, sorry, they mostly belong to the Queen. There's a few in a few specific areas that don't belong to the Queen because they've been specifically allowed to be given to somebody else.
Oh, okay.
So you can eat those.
What about the black one? What about the black ones?
Oh, they're okay because they don't exist. They come from that non-existent country, Australia.
Okay, question 17. Competition for resources between two different species is called what? Is it called predation, interspecific competition, intraspecific competition, or competitive exclusion?
Hmm.
I like Sable Eagle. Self-propelled hazards.
Never look a gift swan in the mouth. They bite.
Yeah, they do. Swans are
Yeah,
mean.
they do. They are.
I'm waiting for the clue. Oh, is that what it is? I think I might answer that one. There we go.
Yeah. Inter meaning between two different things. Intra meaning within the same thing. So there you go.
Yeah.
I got those down working on networks because you do a lot of
Yeah.
work on internets and intranets.
Intranets, yeah. So the correct answer was interspecific competition. Question 18, getting close to the end now. Moving processes from the main memory to disk is called what? Is it scheduling, caching, swapping, or spooling?
I think it's that one.
It's that one.
Not that one? Oh, Donkey's gone for that one.
Yeah.
You copied me this time, then.
No,
I didn't copy anyone. You didn't copy me.
You typed it without looking this time. I know.
I run Linux, so you need a drive for one of these.
Indeed, you do.
You do, yeah.
I'm just a little slow on the typing since it's almost 5 a.m.
Yeah, I've run a few Linux boxes in the past myself.
Geez, you're up late tonight on a Saturday. Or Friday night for you, isn't it?
Yeah, Saturday morning at this point.
Yeah, it's nearly Sunday morning here.
These are the things. Scheduling is what the first diagram is. Caching is what the second diagram's about. Swapping is what the third diagram's about. And spooling is what the fourth diagram is about. So I guess taking things from main memory to disk, the third diagram shows that nicely. It is swapping.
Yeah. I was thinking spooling because spooling's similar, but it is a bit.
Okay.
Okay, question 19. What term refers to the heat needed to change a unit of mass of a substance at its melting temperature from a solid into a liquid?
It sounds like this one I should know the name.
there was me about to type the other one.
Ah.
I don't know.
A couple of ways you could write this, and Clive Wells has chosen one of them. Latent heat of melting. That's kind of half right, Sable Eagle. Clive has nailed it.
Well, of course, Clive's nailed it.
Mm,
Yeah. It's the latent heat of fusion,
okay.
or the enthalpy of fusion is another way to say it. It's the energy needed to change something from a solid to a liquid, or the energy that you need to take away to turn it from a liquid back to a solid. Yeah.
I didn't know that one.
Everyone, John said, I hear what Clive said.
Yeah. And the last question to wind it up. Winds are classed as agents of erosion rather than of weathering because of what? Because they have nothing to do with the weather, or because they carry rock particles away, or because they work only part of the time, or because they build up rather than wear down the rock? So winds are classed as agents of erosion rather than weathering.
I'm actually going to be interested in hearing the explanation behind this one.
Behind this one.
Me and Donkey should be right.
Yeah. The correct answer, of course, is B, because they carry rock particles away.
Yeah.
Okay. I was just saying, if that's not the answer, because all the other answers just seemed really ridiculous to me, and I was like,
Yeah. Well, weathering is the actual process by which the rocks are broken up into smaller pieces. You know,
Okay.
things like impacts from other things, ice forming and expanding and cracking things and stuff like that. You know, but then once those smaller particles are there, the wind comes along and carries them away, erodes them away. Yeah.
Okay. So generally when I hear of weathering, and obviously it's not in a scientific sense, the weathering of something isn't necessarily the breaking down of it.
Well, no, the weathering is the breaking down of it. It's the erosion that's the carrying away of what's been just broken down.
Right. But I mean, what I'm saying is like, if I'm talking to somebody and I'm like, oh, I've got a chair, an old chair that's a bit weathered, or I've got this that's a bit weathered. I'm not saying that it's been broken apart.
Yeah. But you're using the word in a different sense then. Yeah.
Yeah.
In a different context. Yeah.
Yeah.
The chair's been out in the weather, so it's had weathering.
Yeah, right, yeah.
Yeah, literally. Yeah. Fair enough. Well, there you go. There was a 20-question quiz for you.
Oh, thank
haven't had
you.
one of them for a while, hey?
No, we haven't, no. Because I haven't been streaming much on my channel from the beginning of the year. I've been wanting to have a break for a bit, and we're just streaming on Alan's channel just a couple of times, maybe every other week or this week. it's not too regular, but if you're up for it, Paul, and you'll see it in the notifications when I do a Monday daytime one for the Northern Hemispherians.
Yeah, that'll be fine. You know that I can't do the Monday daytime one because I'm working.
Yeah.
That's
Well,
fine.
I get the Americans and some of the. Well, it's late for Alan.
Yep.
That one.
How are the Harvard students?
Oh, they're great. Our new Harvard students, the ones we got about 3 weeks ago, we had a real issue with them. The hatchery stuffed up, and they overloaded their hatching machine, and it didn't cope very well. And so we got about 5,500 little Harvard students, little ducklings. But unfortunately, over the next 2 or 3 days, 1,200 of them died. So, yeah, that was a big loss, but they're going strong and fine now. So,
what happened to the lame duck that we seen on camera one time?
Huh?
The little lame duck, the little one. What happened to it?
Well, the little one. No, the 3 that I hatched here. Huey, Dewey, and Louie.
Yeah.
two of them are normal full-size ducks. The third one is a midget. It literally is a midget duck.
Oh man!
Wow.
Yeah, it
Professor,
is.
I was just going to tell Phil, you missed the quiz.
Yeah, I said that Professor Phil must have dozed off. You're having a nap, Phil. You missed out on all the quiz.
I have a picture of it, but I've got to get it off my phone. Maybe I can send it to Discord and then get it from there.
Yeah, I can share it from there.
Let me do that. Where? Discord. So what?
In Fairsuck will do. It doesn't matter.
Okay, so FAIR Fairsuckle. There we go.
Oh, while you're doing that.
All right.
While you're doing that, I had to show this one before I forget. They were talking about this earlier. Where are we? Transition. There we go. I don't know how that came out over there. Did it come out too small or too big? Yeah, there we go. I can make it smaller. Yeah, they were talking about this earlier in the chat. That there's Blue's little box. Okay.
All right. Well, I can share the screen, Terry, because I've got it up here.
Yeah,
so.
I can get rid of that. Back to normal. You're right. You can go.
Yeah.
John Rapp's mystery picture.
Okay. So is that up?
Yeah.
Yeah, it's up here. It'll come up out there.
Yep. So those ducks are the same age, literally.
Wow.
Exactly the same age.
And what if you kept them? Have you? Or you're able to keep?
Yeah. Yep.
Wow.
So it is literally a midget duck.
Wow.
I've also got 7 other ducklings, which are about 3 weeks old now. They're from that other batch here at home. And they're about in between. They're about halfway in between those 2 ducks. So the 3-week-old ones are about 3 times bigger than the little one there.
What's the little one's temperament like in comparison to the full-grown one?
Well, it's not as like it's. I put it in with the big ones for one day, thinking that it might like the company, but the other ducks just ran all over it, and the poor thing, it was upside down, and they'd stood all over its beak, and its beak was bruised and bleeding, and it was like almost dead. So I rescued it, and it's got its own separate little yard now. So the other ducks
So
can't.
they literally walk all over it.
They literally walk all
Yeah,
over
walk
it.
all
They
over
don't mean to. Like
Yeah.
they weren't picking on it or anything, but they just have no regard and just tromped it
Yeah.
basically.
Yeah, you're just a little
Knocked it
duck.
over.
Yeah, we're bigger than
Yeah,
you.
yeah. So it's got its own little yard now. So it's been rescued. It's got its own little yard. That photo was taken yesterday.
Wow.
So yeah.
So what's the name of the
So
little one?
Oh, I don't know. I haven't really given it a name. I'll have to
Mm.
call it something that means midget.
Well, if you end
won't
up, what's the lifespan of it? You can keep it for its natural life.
I? Oh, well, I don't know. They'd last for ages, I guess. But I don't know what the lifespan of a duck is. I know with the Lover Duck Company that it's not very long. they go to the processing plant and say hello to the big machines.
Get processed.
Yeah, that's right. But it's obviously still got its baby feathers too. It hasn't got adult feathers either.
Yeah.
It's still got its baby fluff.
It's
So,
weird.
yeah.
Yeah, it's. I think it's not so much midget that it hasn't. It literally just hasn't developed.
Yeah, that's right. And like the other duck is a female, and it literally quacks, like it goes quack, quack, like a normal duck would quack. But this little one, it tries to quack, but all that comes out is beep, 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 beep.
Micro duckism.
Yeah.
Have you captured the echo of the duck?
Oh, duck's
Yeah,
echo.
I've just literally got hatching tonight. Actually, some little mini frizzle chickens. They're just hatching out tonight. I've got 2 hatched out already. So yeah, little mini frizzes. They're tiny little cute little fluff balls. I'll share a picture of those too. Let me get one of those up. Where are we?
The ducks use the same salt as me.
Little wolf.
Here you go. This is what just hatched out a few hours ago. And I've got about a dozen more. Probably going to hatch out overnight. Yeah. Little balls of fluff.
Yeah.
Yeah.
So how long do you keep them?
Oh, these ones I'll keep because I want to breed these ones. So, yeah, but the ducks, I'll keep 2 to breed, like for eggs and to breed them. But the rest, the rest will end up in my
graduation.
Yeah, they'll. Oh, what was that movie that when you get to a certain age, you have to
Logan's Run.
Logan's Run. That's right. Yeah. Yeah. Well, that's what's going to happen to the ducks.
Yeah, but like when?
Probably about when they're about 9 or 10 weeks old.
Oh, okay.
Yeah. I know at the processing plant they only get 5 weeks, 35 days. They get
Oh,
to grow
wow.
and process them. Yeah, 35 days, and then they're at that age. They grow so quickly that they're about 3.5 kilos already. So yeah, yep.
Are they full grown within that time then, or
They're full size, but they're not they're not mature enough to lay eggs or anything like that. No.
right, but they're not going to get any bigger.
No, they're not going to get any bigger. No. No. Yep.
And I'm guessing, of course, that you also want to take them when they're at the size that the customer is going to want.
Yeah, that's right. Exactly. That's correct. Yeah. Yeah, and of course, if you leave them go longer too, they get tougher. So
Yeah, you don't
Yeah.
tough meat.
Yeah.
Yeah.
you don't want tough students.
Well, that's the same as chickens,
dinner.
really. You don't want old chicken. You don't want an old
Yeah.
chicken.
Yeah, an old broiler.
Mm. That's
Yeah.
Mutton instead of lamb.
it. Yeah, that's it. Yeah.
Yeah.
Oh, thanks for that, Paul.
Anyway, there you go.
Well, that's your lot for tonight, folks. We've been going a lot longer than what I thought we would have. But,
Yeah, because you didn't anticipate having Durban quiz, right?
well, that too, yeah. And we
Yeah.
took a bit longer with the McToon video as well.
Yeah.
Had we, well, I'm sure had we realised there was a quiz going to become available, we would have chopped it down a little bit. But,
Yeah, we might not have done as much as we did. Maybe we might not have had the extra Lindsay.
Yeah.
Oh, thanks again, Alan, for letting me stream on your channel. Thanks, Donkey, for dropping by. Thanks, Paul, for your late coming, but you come
Yeah.
through with your quiz and a bit of dirt. And Blue, we couldn't get a word in most of the time because Blue wouldn't shut up. So, and the Peanuts, everyone from Dave to Little Wolf, Carl, Demon Orb. Oh shit! I have to keep going right up. Clive,
Dora.
Dave, Milkman Dan. I'm going to miss a name here somewhere. Yeah, Clive, Little Wolf, Sub Eagle.
Professor.
Oh,
Phil
Pip
Dillon.
was out there earlier. Pip was out
Yeah,
there.
oh, yeah.
Pip was out there earlier.
Professor Phil, don't forget him. I don't know how far I can
Don't
scroll
forget
up.
Raimi, who was also on the panel for a while.
There was a huge ass out there too earlier. I thought I seen
There
one.
was.
Yep.
Yep.
Jinx you. Oh, okay. I think I've nearly got the generics of who was out there. If you've missed your name, you can retype it again quickly.
Brainery.
Oh, Brainy,
Oh, yeah.
okay. Oh, Dora. There's Dora's putting out. There we go. And we'll see it probably. Oh, if I do Mondays, I'll do a reminder for Alan. You'd have to let me know tomorrow night, Alan. What's today? Saturday, Sunday. Yeah, I'd have to speak to you tomorrow night if you can do Monday.
If you want to do your Monday lunchtime stream, I'll set it up for you so that you
Okey-dokey.
can auto start it and auto stop it.
All right then.
And,
Okay.
and I might not be about.
That's okay then. Okay. And I'll promise I won't get you struck.
Yeah, promise me that one.
Okay, guys. If you want to come over to Discord after for a coffee and biscuits and cake, you got to bring your own coffee and cake, obviously.
Oh, what? You don't have enough to share?
All right then.
I
Good night.
come all the way. And
Expectations. Okay. Yeah. Okay. Good night, panel. Good night, Peanuts.